Good day and a very welcome from my side. My name is Martin Heinz. I'm the CEO of iTAC Software AG, and I'm very delighted to welcome you today on our first Smart Factory Summit 2025. So what does it mean we? You see it on the top side. Me means iTAC together with the sub-brands DUALIS, Cogiscan and Accevo. So we prepared for you today a agenda with a lot of different points to address the current needs. And you saw it already in the invitation. So starting with a short introduction and welcome round, and then starting directly into a topic of GenAI, then going forward with optimization production, and all the different, let me say, topics and presentations are related to production and to face the question how we are able to overcome challenges, how we are able to overcome pain points. And it's not the aim today to have a kind of a function and features presentation. It's really coming from a use case and to present and explain where we are and what are from our perspective the different options to go forward exactly in this matter. So going forward with the introduction. So I'd like to highlight as well that we as iTAC and all the sub-brands are belonging to the DUA group. So that means we are part of the DUA group. Maybe some of you already know DUA group. It's a large organization, more than 20,000 people acting all around the world. And the focus of DUA is mechanical and plant engineering. And there's a quite strong focus on automation and for sure as well digitalization. And that's the reason why I'm here. And let me say the production portfolio out of our iTAC units, they are part as well of the whole offering of the DUA group. So what does it mean if I am talking about iTAC units and sub-brands? You see here, we are acting as experts with a strong competence in digitalization into the manufacturing area. For sure, different companies addressing different, let me say, main topics, different areas. Starting from the left side, looking shortly to iTAC Software AG. So the main target on the iTAC side is MAS and MOM. And in addition, since 2 or 3 years, we have as well a solution portfolio if it comes to manufacturing analytics. So the focus on the iTAC side is pretty much focusing on discrete manufacturing. So different industry sectors are related to discrete manufacturing. That means automotive, industrial, and all the different things you see there. And iTAC is a global acting company. And on the right-hand side, you see as well, iTAC is as well located in China. So that's our own team located in China, Chinese people, to be able to act as experts as well into the Chinese market and in the rest of Asia, with the same focus than the iTAC IG. So, and that's belonging all together as a, let me say, solution delivery. So together with us, we are acting together with DUALIS. That's a daughter company of iTAC. DUALIS is focusing on production planning, means advanced planning and scheduling, and factory simulation. That means process simulation and material flow simulation. And for sure, if you take a look at this kind of a product, then it's related to the discrete manufacturing as well. But there's as well some overlap if it comes to process manufacturing. So you see as well focused on industrial areas, metal fabrication, injection molding is a quite huge footprint, automotive as well, electronics and as well machinery. And last but not least as well, we are as well in on DUALIS side in the food area. So Cogiscan, the colleagues from Cogiscan, they are located in Canada, are pretty much focusing on electronics production, which comes from the SMT production, but as well the production steps after the SMT. So there's a quite huge footprint on connectivity, on different functionalities. And together with iTAC, there's as well a common solution portfolio if it comes to integration of SMT and electronic production. And the same way, we have as well a joint portfolio together with DUALIS, combining the DUALIS portfolio with the iTAC portfolio. It means APS and MOM as a common solution. And on the right-hand side, so that means the newest member, so to say, into our organization. It's the company Accevo. Accevo is located in Poland. Addressing from a, let me say, overall perspective, more or less the same topics. It's as well related to MOM, related to MAS, but the market is a little bit different. So Accevo is as well able to go into the fast-moving consumer goods market. Is a little bit different to a, let me say, origin discrete manufacturing. They are as well in tobacco, pharma, automotive, and as well in defense. So, and you see as well, right, we are acting as a company, and that's why we are here to present our portfolio and to show which kind of functionality and solution we are able to provide for this specific market to address different challenges and pain points. So why we are able to do that? I do not like to shock you, right? Only a few information. And you see here, iTAC is already founded in 1998. So that means over 20 years experience. We are more than 140 people acting all over the world. So that's a quite large footprint on the iTAC side. As well together with DUALIS, more than 30 years experience in planning solution, and as well in simulation. So as well a quite footprint as well on that hand side. So looking to Cogiscan as well, founded 1999. So more than 20 years experience in everything which is ongoing in manufacturing on electronic side, with a quite large footprint in different connectivities, data management, as well as traceability. So this will as well fine organized on that hand side. And last but not least, the company Accevo, which was former named ANT, founded in 2006. So that means roughly 20 years experience. So that's the reason why we are here. We have more than 20 years experience in all the different companies, a lot of experts in our organizations, a lot of customers we have. And the aim for the day is to show you the challenges we see in the current market situation. So the companies are facing with sustainability, question about flexibility because changing in the market demands is changing, and as well the situation from a, let me say, geopolitical situation. There as well some changes which leads to a flexibility at the end, which comes over to supply chain management, product quality. All the different things are needed to address as well at the end at point 7 into a kind of digital solution. So, and that's the reason why we came to the conclusion to go into a kind of a summit, because based on the knowledge we have and based on the experience on our solutions, we like to show you how to master the challenges in production, the different points we like to address on. So how to overcome the pain points which are demanding more and more, and how we are able to support a different strategy to be successful at the end. So, and therefore there are for sure different products and solution already in the market, already defined from MOM to APS, AI, IoT, emulation and simulation. And that's exactly what's behind the agenda, right? To give you an overview concerning a use case, a situation, and then explain how we would be able to solve this kind of a pain point, or how to drive a factor to be successful at the end. So that's the short introduction, and then I'd like to go to the next before we hand over to Andreas to the first topic, so to say. I'd like to give you the information. So what we are doing is we are planning as well to having a 5-minute Q&A session after each presentation. The chat functionality is deactivated, but nevertheless, there's a button in place which is defined as a Q&A button. You can use the Q&A button, and then we can use your questions directly after the presentation and to start answering. And if we have not enough time to answer each of the questions, then we put it into our backlog and answer that afterwards, so that you have further information afterwards. So then I'd like to thank you for listening and thank you for your participation. And I'm delighted to take over to Andreas. Andreas, it's your turn.
Oops. You can understand me of, yeah, just short indication, Martin?
Yes, I can understand.
Oh, perfect. So welcome everybody. Intention for this part of the presentation is to give you an insight into GenAI, which gives you information about production processes, preventing downtime and optimizing throughput. I would like to address some challenges that we want to cover, give you short insight into GenAI. Of course, what does it have to do with our iTAC MOM suite? Give you two examples, including one real-world example showcase or example in the description how it works or should work, some measurable impacts, and also a roadmap and vision about the progress, what we are going to do as iTAC Group. So let's directly start with our introduction. Typical things that we have in our production environment is that machine downtimes cause significant productivity loss. There's nothing new to all of us, but it's a typical showcase where GenAI can help us. So what is an issue? Why a downtime causes significant loss? Sometimes it's not clear what the reason of this downtime is. So maintenance operators especially are driving root cause analytics based on their knowledge. And the longer these operators are in place and the more knowledge they have, the faster they can solve these issues. Very often they do things and document it in a very short way. So in terms of troubleshooting, if someone else is new to the topic and has to solve a similar issue, he has to run through the same analytics as someone who is experienced. So it's time consuming, and finding issues is also error prone. So sometimes it's try and error until the production line is again up and running. An additional thing, also not new, but I think it's also a very important topic, especially in finding root causes, is that the data from machine systems connected to the production systems, also human information, is uploaded and stored in data silos. Information is not really connected, and that makes it quite hard to analyze what is going on. And it's more a reactive process than a predictive or process that prevents things. Means, as a result, it's very often an inefficient process. It's rising costs and it's causing unplanned delays and also very long delays. GenAI is something that can help us in the manufacturing to make very complex things a little bit easier to understand using natural language tools and interfaces. First of all, it's important that GenAI does not do something magic. We need to understand what GenAI has to analyze, and we need to generate a context. So the most important thing is to contextualize what is available so that GenAI can use this, let's say, unstructured data to get content out of it, and so that people can ask questions, as you know this from ChatGPT or Copilot or something similar tools. Typical things that we use already in our environment is documentation. For example, technical manuals can be used to train GenAI. Log files, station logs can be used. Standard operating procedures can be used, which describe how specific processes in the shop floor need to be executed, including also information about tooling, how to set it up, how to use it, how often it may be used until it is to be maintained. All this kind of stuff then leads also into production records. For example, in a discrete serialized production, we know exactly what is being done on which machine, by which operator, with which skill set, and so on. All the parameters, humidity, temperature around, pressures of a machine can be uploaded and can be used for training, of course. And the result should be that we ask a question and GenAI gives you the answers, explaining root cause and guide you through the troubleshooting. Key features are definitely conversational interfaces, typically by text, or can be also included with voice commands. and gives you fast document retrieval and summarization of the issue that you have. And if you want to have it more precise, you can ask for it, and it goes deeper and deeper into the analytics and gives you more insights. Very important is that it is also combined with continuous learning from real-time input. That means that during the time, the knowledge base increases and the trained data increases, and the quality of the answers is getting better and better. iTAC MES and iTAC MOM Suite, for all the colleagues that know the product quite well, this is for us the foundation of real-time or near real-time inside production control, track and trace. And from the MOM platform side, we have two different product approaches. The first is iTAC MA Suite. MA stands for Manufacturing Analytics, which is, from our point of view, the entry solution that helps us to get data very fast from the production and produce value very soon in terms of fast analytics, providing dashboards with important KPIs. So a project can be driven very, very fast in comparison to an MES MOM project, which is, from our point of view, very, very important in terms of production control. So this is, I named it the digital nervous system of the smart factory. When you want to enable a smart factory, you need special features for interlocking, for avoiding issues, and the MOM Suite comes with exactly these features. So in total, with our MOM platform, we integrate production data in real time, near real time, of different dimensions. And the dimension is, for example, machine, equipment, material, processes, process data, operator information, maintenance information, so that you get transparent production overview, also including the quality information, quality processes. Speaking about modules, typical things that we do there is traceability, production management, so looking a little bit into the direction of KPIs, and quality management to check where are the main issues, what are the main root causes, and maybe to do then analytics to avoid them upfront. Maintenance of equipment, machines is one important part of it. And of course, analytics, either in terms of dashboards, reporting, but also in terms of near real-time SCADA dashboards. And the most important thing, of course, is connectivity to every device, to every machine, also including human-machine interfaces and more. And this is for us the ideal foundation to do, in general, AI-driven services and also AI-driven decision. As I said, let's have a look at two use cases. Use case number one, Ask Our Doc, which is a product which is part of iTAC MA Suite, is typically a feature with which operators get the tool to use documentation, to use any kind of information that is uploaded in the training process and analyzed. And the goal is definitely to get an accurate answer for the operator based on a technical question. Elements that we use, as I said before, machine documentation, standard operating procedures, work instructions, but also additional documents can be used like error code manuals, historic service logs, and then the natural language interface gives you the option to ask a question similar to, what should I do if the soldering station temperature fluctuates? And I did it on basis of the documentation that we have already. You see it on the right-hand side in this small box. So the system checks, browses all the documents that we have. It checks available documentation and gives you some steps to handle exactly this temperature fluctuation. So it's an option to use it to reduce the downtime, because this is a hint where you can solve something. And it empowers people, especially maintenance operators that are less experienced, so they can ask questions and find hints without browsing thousands of pages in PDFs. So it's much faster to find the right information. And it shortens, of course, also onboarding times. And we have a centralized knowledge database, which combines nearly everything. A second use case is the manufacturing analytics use case. It's also based, of course, on a kind of documentation which is available, but we have to add additional things. The main purpose here in my example in this use case is detecting a root cause and acting then before something happens in the shop floor. So to get data from the shop floor, facilitate this data, and to have actionable insights. Typical data is information coming from the machine directly. So every machine activity, every process information, either directly from the machine, from the conveyor, from the sensors. So typically the data that we collect in iTAC MOM suite can be used to get this contextual information that then is used by GenAI to analyze and explain trends, anomalies, and root causes. So similar dialogue, you have this special interface similar to ChatGPT or to Copilot, and you are allowed or you're able then to ask questions. Question examples are, why was OEE below 70% last week? Or which line had the most rejects and why? Predict next likely bottleneck for line number 2. So these are typical questions that you could also get by reports, dashboards, but then you need exactly to know what is the location, what is the URL, what is the dialog that I have to open, what is the report that I have to open. And manufacturing analytics will, in the future, assist you exactly here. So you do not necessarily have to open that dashboard, that report. You can ask in the future the system and you will get the answer. So the benefit definitely is a better and immediate insight in what is currently going on for planners, supervisors, and the time for decision is much faster because you ask the question and you get the answer. And definitely something to improve the process in terms of quality and also throughput. And there's also a possibility to improve the database, of course, to get more and more content into the system, because it's not only that the machine, the sensors, and passive systems feed our system. Also, people that are using this application need to feed the system. So when you have, for example, a downtime, and at the beginning, it's not clear enough maybe what was the root cause, then operators very often have to key in the details. What was the message before? What was maybe a side effect that led exactly to this downtime? And you can improve the database to get more and better information from the system. So in general, using use case 1 and use case 2 manufacturing analytics and our Ask Our Doc is that you turn your reactive teams that react on issues or on bad KPIs into proactive ones, so that you can do something upfront before it really appears. And I think this is a very important and good message. So in terms, just to see what one example could look like, just as a walkthrough, similar as I said in use case number 2, a problem could be we have a throughput on production line 7 dropped by 12% over the last 3 days. And the production manager is now asking simply in our Ask Our Doc interface, why is throughput on line 7 declining? Typical way how that would be processed is that GenAI will analyze what is going on with the contextual information coming from documentation, from the machine, documentation from the shop floor, coming from the MOM context, and put it together. With this information, it detects maybe in this case that there was a gradual cycle time increase in the pick and place unit. So we needed simply more time in the pick and place unit for picking and placing components. And it checks all available information in parallel. So cross-reference historical logs, for example, can be validated, and then it finds a correlation and an equipment issue. Maybe the equipment has been used and there's still some time left for maintenance, but due to the fact that the cycle time is increasing, the result could be that it needs to be exchanged by an already maintained equipment, and then the cycle time decreases again enormously, or is in a way that is acceptable again. So the GenAI gives you information about all the correlations, all the big information that is in the database, and gives you then in this way information how to solve issues. And additionally, it can also alert maintenance operators before this issue appears, or even the production line fails. So as a result, the issue can be resolved using GenAI proactively, more proactive as before. It can avoid a full stop of production line because it can alert people before we have an issue. You can save the potential downtime of maybe several hours. And definitely, and this is, I think, very important, it will improve the team's trust into systems, digital production systems that are in place. So it's not only collecting information, it's also helping them during their daily process, doing, for example, operations in maintenance area. When we look at the business impacts, typical KPIs and ROI questions appear. So what we could expect? Definitely downtime reduced. We will not quit it, or we will not get it down to zero. We will always have side effects, but it's definitely reducing downtime. Operators, first level support, resolution rate will be much higher, much easier for them because they have a knowledge base that they can use. Meantime to repair resolution is radically reduced. And the backlog in terms of knowledge backlog that needs to be processed and maintained somewhere can be eliminated. And the ramp up for people that are completely new to the production process and maintenance area can be cut enormously. Let's have a look at the vision and the roadmap. We as iTAC Group are evolving towards a fully integrated intelligent MOM platform. That means that we have the goal to couple the solutions from all software components that we have in our group, from DUALIS, iTAC, Accevo, Cogiscan, and DXQ Control, so that with a unified data model and semantic layer, we can share information that makes it easier to understand what is going on and exchange it and use it in GenAI, so that we get an end-to-end process from planning to execution and, of course, to analytics to improve the process quality. And the contextual AI will then use all the data that we receive exactly from these areas. That means planning, maintenance, execution, quality, and put it into, as I said, into context so that questions can be asked and the right answer can be expected. But of course, also in terms of personalization, it's important to know that people have certain roles, locations, and tasks, so not everyone is allowed to do the same thing. So these are things that we need to look at in the future. Feedback loop for model refinement is also important in terms of how do we improve models. We definitely need people that do user confirmations, that do capturing of additional information, especially when something happens that has not been expected. So it is a continuous improvement going on, but the benefit is this improvement, this tool set can be used based on our contextual database without training at the beginning. We can start from scratch with context information. And this is all something that we are scheduling for end of this year. So to finally sum it up, what are the key takeaways? GenAI turns definitely everything that we have into instant knowledge, documentation, database, content, and so on. And the manufacturing analytics suite and MOM suite are the enablers to drive into this direction, data transparency, and of course, control. Ask Our Doc and manufacturing analytics will help you to be proactive in the future so that we have less downtime, more throughput, and definitely better decision. So Ask Our Doc extension will come soon, and I'm happy to answer your questions.
Well, thank you, Andreas, first of all, for the presentation. I think that shows that artificial intelligence is not just a matter of the future in production, but also right now in the present. So also, first of all, a welcome from my side. I will be moderating the Q&A sessions after each presentations a bit. So if you do have questions, then you can use the Q&A button and ask questions. There is also the option to ask questions anonymously if you wish to do that. As we are right on time for the next presentation, I would say we skip the Q&A session, Andreas. In case there are any questions left, we can answer them afterwards. That's not a problem. But I would say since Sebastian is already here in the stream, we continue with the next topic. Sebastian from Accevo is also here, and he will present some digital tools for production optimization. So if you're ready, Sebastian, you can share your screen and start with the next topic.
Okay, good afternoon, everyone. I share my screen. I hope you see it.
Yes.
Okay. Again, thank you for today. My name is Sebastian Pesch. I'm from Accevo. I'm the new business manager. And today I would like to focus to key digital tool to help maximize your performance on your production. In this case, I would like to show you our customer cases where we implement the OE performance monitoring and microstops monitoring. I try to tell you a little bit more about this tool, but before we start description, I would like to tell you about the challenges which give us our customer. Of course, the most important for us and for customer, of course, is a connection with the machine. So customer want to connect with machine, and it's not easy for us because on every production we have different age of the machine. Real-time data is very important because we take the data from the machine and we can check the line performance on our production. The next challenge was manual data collection, which is time-consuming and created the problems, the errors prone. So in this case, we would like to delete this problem. The next one is the no clear data to identify the root causes of losses. It's difficult to check where we lost our efficiency if we have data after few hours after in the next days. So this is the challenge. The next one is difficult in tracking and improving OE over time. And the last but not the least is standardizing performance metrics across line and sites. This is the challenge which give us our customer, and now I try to explain how we solve it. First of all, we need to connect with the machine. Since 19 years, we have experience in different machine connections. So in our opinion, we know it very well how to do it. As you see, we have different kind of connection with the machine because, like I said, the age of the machine can be different. If the machine is very old, then we can add the additional cells or like I/O modules, like cameras and any other necessary thing. This is the example of our production, of customer production. For example, the blister machine is connected to our system by OPC-UA. Check weighers, like for example, Metal Toledo, is connected by their own protocol. Serializer case speaker is connected by PLC, but it's not that easy because we have different producer of PLC with different industrial network, like Siemens Profinet, for example, Allen Bradley Ethernet IP, Beckhoff EtherCAT. So in this case, we don't have easy way to connect with the machine, but like I said, we have 19-year experience, so it's not difficult for us, and we do it well. Our team have very high experience. The next thing is master data and connection with external system, mainly with ERP system, but not only, of course. We call very often, we need the one source of truth. That means the master data should be in one place. In this case, if we don't have connection with external system, of course, we create the data in our system. But if we have a interface, then we create the both side interface. I mean, customer change something in ERP system, and then we have a very fast update in OE system and in different way. Because the data should be always the same in every system in customer facility. As you see on the slide, it's possible to connect with every system existing in customer facility, and of course we're ready to implement the system, our system on server on premise or on cloud. This slides show how it's looking the operator panel, and this is the real slide from our system. We have here the most important data like order, like start production in plant sequence. We have state of the machine, and we can give all this data to operator. Operator can call technician and know what he's producing right now, what is the order, and focus on customer KPIs. Now I try to explain a little bit more about the microstops and microstops monitoring algorithm. What exactly mean the microstops? The microstops is very short break on customer production. For example, under 1 minute, but the time depends of the customer. How is working microstops algorithm? We are connected with the line, but not only with the line, because then we don't have too much information. We are connected with every single machine on the line. That give us the very big data and can show us can detect the bottleneck on the line. That means if you checked on the slide, then you see the red lines. That means the single machine on the line have microstops, and we have information for the line. Is this microstops have impact on the whole line or no? Then we can very fast react and check what's going on our line. Here we have more details, and if it's necessary, and always is necessary, we can focus on every line, on every machine. Then we have, like I said, real-time data with microstops on our production. Every single step on the production, on customer production, is important. In this case, we can create together with our customers operator checklist for every single step on production, with steps for every single station on the production. This checklist can be connected with orders, with items, and with the machines. That means the operators see only steps dedicated for his station. We don't want to show him all big description, instruction, just important steps for his station. For example, in this case, we can check how it's. We can create for the operator the changeover list with every single step. After the changeover operation, system generate, of course, the report, and customer can compare the real-time changeover to default one, for example. Operator give the feedback for the system, but operator have a feedback, but the system give the feedback for operator. So in this case, he knows very well what's happening on his line, and he can react very fast react on any deviation in real time, what is very important for OE and for performance of the line. To make it as easy as it's possible, we together with customer create state for every machine connected to the station. This is the first step of one of the first step of implementation, because it can be difficult. That's, I mean, some customer can have a lot of states on different machine. We create, for example, that view for our customer and for operator. So in this case, he can choose only the state existing on the screen. He cannot change nothing, so it's easier for him to, and we don't want to lose his time. He need to focus on the production. KPIs definition and how we calculate the OE. Our system can standardize OE calculation, which help compare data for different factories in the same company, because different factories can calculate OE in different way. We can standardize process to calculate OE in every location. In this case, customer can very easily compare the data from different location and increase his OE. Because we have cases where when our customers show totally different OE on the same line but in different factories, when we focus on this numbers, then we have a conclusion. They use the different model of calculation OE. So in this case, we try to eliminate this problem. Because every single production can be different. We together with customer create the state, the master data, and in master data we have a state of machine. We create the state, and the state is connected to the machine. Then, like I said, we create the mask for the operator, and they can choose only the existing state on their machine. We can decide together with, customer decide, is the state have, we create the OE category, and customer decide is the state have impact on OE or no. Here we have a road queues analysis. We can analyze very deeply what's happening on our line. We can do it. We can check the trends, for example. We can check the trends in long-term time if it's necessary. Then we can, if we make an analysis of the trend, then we can make some changes or change some steps on our production, and we can check is it has or hasn't impact on our OE. This is the example of the trend. Finally, if we create the state and put every important information to master data, we can create the OE loss tree. This is, of course, we have a lot of performance dashboard and panels, but OE loss tree is, in our opinion, one of the most important, because here we have a clear information when where we lost our efficiency, our performance on our production. In this case, if we create more states on the machine, if we create more OE category, then we have more information and bigger data to analyze how to solve and how to increase our OE and our performance on the production. Okay. Of course, we can create the reports in our system, but if the customer can do it in different way, like for example in Power BI, then we are open on that solution. Of course, we have ready interface. We call them data warehouse lake, and we can send the package of information to Power BI, because, for example, in our system, the local production manager can create the reports, but globally for all factories, all facilities in all of the world, the headquarter will be do it in Power BI. So in this case, we can send the data to the system, and customer will do it like always. Of course, our system is ready or on AI, because it's a very hot topic right now. Okay, after that, after implementation of system, what we have, what outcomes and out benefits we have. Of course, the machine connectivity is better because we have measuring in real time and collecting data in real time. Microstops monitoring is responsible for finding the bottlenecks on our line, and the bottlenecks is easy to detection for our customer. We reduce the waste material. We reduce the raw material consumption because the system can give the operator and not only shorter reaction time. We have what is very important, because this is the big problem. We have all data in one place. I think it's good moment to tell you OE and microstops monitoring is a part of our system. Very often we start with single module for our customer, and then we develop the system and add some functionalities like energy management system, for example, or CMMS system dedicated for maintenance department. So in this case, we are a partner which can give you more or less every system connected with the production, quality system, paperless, and few others. And the KPIs overview. The customer have a big performance and a lot of dashboards inside our system, visualization on real-time data, and decision process is better, is shorter, and they can create the new rules, the new steps, or reduce the steps. What number give us the implementation of OE system? We have OE increase between 12 to 17%, microstop reduction between 14 to 20% on the production, material waste reduction around 8%, and reduction of changeover time between 10 to 25% of the time before implementation the system. From my side, about the digital tool, it's everything. I think it's a good moment on the question. If you have any question, just let me know.
Yes, thank you, Sebastian. First of all, let's see if we have some questions. I will check. Yeah, we have one or two. First one would be, can the OEE system connect to any ERP system?
Yeah, of course. It's not a problem to connect with any external system. Of course, we have on the market some big players, but our customer have really different ERP system, and not only, of course, ERP system. So in this case, we are ready, and we have experience with creating interface to every, I can say, every ERP system on the market.
Mm-hmm. All right. The second question would be, is it necessary to connect all production machines to the system, or can we do it step by step?
Yeah, it's a very good question, because it's a very topic to discussion with our customer. We recommend to our customer to implement the system step by step. So in this case, it's a good opportunity to connect, I don't know, one line, one building one factory, yes, no problem. But if we do it step by step, then it's easier for customer because we know very well the system. But like always changing the system inside the facility, inside the factory is something. It's a big event. So in this case, we recommend to do it step by step. And then it's much easier for the customer. And in the future, he can connect the single machine, single line on new facility. It's not a problem for us.
Mm-hmm. I see. I see we will have one more question regarding GenAI, but we will cover that later on.
Okay.
Regarding your topics, there are no questions right now. I would say, I mean, we are in a flow right now, so I would say just we continue with the next topic. And I think Raik is already here to speak about shop floor resilience, how to enhance shop floor resilience, to be more precise. So, Raik, if you are ready, I would say you can start a bit early so you have more time for your presentation. And yeah, in case there are any more questions, just ask the questions and we will cover all of them afterwards if we don't have the time.
Okay. Okay, then.
So you can share your screen.
Yes, I will do. 1 second. There. Okay.
Yes.
Perfect. Do you see my screen?
Yes.
Okay, perfect. So then, hello everyone and welcome to the Smart Factory Summit. So my name is Raik. I'm Vice President of Planning Solutions at DUALIS. And as Alina mentioned, I'd like to explain you how we can boost up your shop floor resilience using agile disruption management and simulation. And so I'd like to explore you to explain you how you can move from reactive firefighting more to proactive strategic planning. On the next 20 to 25 minutes, I will cover 3 topics. The first is we will have a look why resilience on the shop floor is so important. After that, I will explain you why the combination of iTAC Mom Suite and Gunplan is a good resilience weapon. And finally, I will give you a live demonstration and leave time for your questions. So then we come to the first topic. So let's have a look at the challenges. As you know, manufacturing operations today are under constant pressure. So from both sides, from external and internal sides. So when you think about maybe supply chain disruption, machine breakdowns, capacity bottlenecks, or maybe staff shortage with the reason illness or maybe qualification of the worker, or maybe you have unexpected regularity changes, or your IT system has a failure, and then you will see why resilience is so important for you. Because each of these issues can delay delivery, raise your costs, production costs, for example, and the most important thing, the customer satisfaction. And the question now that we like to answer is how we can help you to protect you against this. So, and we begin with what does this mean? What is shop floor resilience? So it's the ability of your production environment to resist and recover quickly from disruption. So without losing performance or production quality. And there are some few key reasons why this matters. Because minimizing downtimes, because every minute lost can mean maybe missed deadlines, or in the hard way, contract penalties. Then staying competitive. Resilient companies adapt faster and deliver more on time. So, for example, be a little more willing to take risks with short time delivery commitments because you know that these have been checked by an APS system, for example. And when we now have a look to our 4 main objectives, the first one is rapid response. So the system needs to detect and react to issues very quickly, because you don't have it's not good for you when the system takes hours to suggest solutions, because you can't wait so long. Then the continuous improvement, learn from each disruption to prevent the next one. You don't want to fix the same problem over and over. You want a system that helps you to learn from the past. Then the resource optimization. You try to make the most of your resources, out of your resources. For example, machines, people, material, and in combination, and with stress in the production. Because you don't want to have a schedule, for example, with idle machines and overloaded workers at the same time. You try to have a good performance of both. Then the sustainability. Resilience is not about the next shift. It's about the long-term operational and environmental responsibility. So then we come to the MES and the APS. On the left side, you see an MES, manufacturing execution system, here with the iTAC MOM suite or the systems from Accevo. And on the right side, you see the APS solution of the iTAC group, GunPlan. And how do we implement resilience? And the most effective thing is that we have a real-time integration of MES and APS. The MES give us the real-time view, what's happening in the shop floor now. And the APS give us the forward-looking plan, what should we do next. Let me give you 3 examples of these 7, I think. Yes. When a machine suddenly breaks down, the MES detects this in real time and alerts the APS. The APS can immediately reschedule affected jobs on the machine that's break down. Instead of a production stopping, your plan can adjust automatically with minimal disruption. Then the second example would be, imagine a supplier delays a critical raw material. The APS can simulate different planning scenarios. Maybe you can produce the same material with an alternate bill of material, for example. When it's not possible, maybe you have to wait for this raw material, but the APS decides which order takes place on the machine instead of the postponed order. So the system shows you the impact and the options. And so you can decide what is the best one for you. The third example would be the worker starts an order with a different setup on a machine that doesn't correspond to the planned order. So now the machine has a different setup. The APS gets these information from the MES and can do a rescheduling to the changed setup. And so you will get a new updated plan with a setup optimization sequence. And in all of these cases, the combination of real-time feedback and simulation-based optimization makes resilience so important. So, okay. So now we come to the software solutions. Now you see some of the functionality of GunPlan. So we have a very flexible cost-based optimization algorithm with 7 target criteria. For example, you see here on-time delivery and utilization, work in progress, setup costs, and so on. And you decide what is more important for you. We schedule against finite capacities, so work centers, workers, production tools, raw materials, and so on, and as well qualification of workers. So when a work center is not available because of breakdown, or maybe there is another operation already scheduled on it, so we are not allowed to schedule another maybe very important operation on this resource. So with that, we have an optimization along the complete value chain, not just for one department. So when the planners currently plan with Excel, for example, they have their department optimized solution, and with Gunplan we have the optimization for the whole plan. And with the bottleneck-based scheduling, we decide when you have to do what and not to produce or to produce parts too early before the due date. And as you know, when disruption occurs, chaos can quickly break out. But with the integrated systems and real-time transparency, you get the clarity you want. And you know where the bottlenecks are and what are the best options for you, because the system knows the machine states, the worker availability, the due dates, the production alternatives, and so on. And with the alerting system, with the alerts in the system, you get the information live from the system, and now you know when you have to act maybe in the planning system or in the MES. Okay, so now we come to one of the important things that I will show you in the live demonstration as well, and it's our scenario mode. With the scenario function, you have the possibility to do what-if analysis. So you can imagine this as a digital test lab, where you can explore the impact of the different decisions before you bring them to reality. Let me give you some examples, and I will show you them in the live demonstration as well. So what happened if I add another machine, for example? Maybe is it worth or not? So, or is the bottleneck somewhere else? So maybe you can decide, okay, is it necessary to buy a new cost-intensive machine, or my bottleneck is somewhere else? What's with different shift models? So when you don't run 24/7 at the moment, maybe one shift per day, then you can decide, okay, maybe to extend the shift at the weekend. Does this one-off exception help you, or do you need to do this more often, for example? Or production versions? Is it possible to produce the product maybe with different routings or with different bill of materials? So the system can help you to find these solutions. So an example is, imagine you can produce the product on a slow manual work center. Yeah, it takes longer, for example. Or the alternative is, or a standard is, to produce it with a faster automatic machine. But when the automatic machine is totally overloaded, this can be a good alternative to go to the manual work center. And with these simulations, you get a deeper understanding of your system dynamics. And that leads you to get better and faster decision making when disruptions hit. So, okay, come to the again to the scenario analysis. You see on the left side some questions, and on the right side the answers for that. And the ability to test what-if scenarios before you're committing is what move you from hypothesis to reality. Instead of guessing how to change, you will simulate it. And the result is that you have a smarter planning, less risk, and more confident execution. And when you remember, it's not just about solving the problems, it's about to preventing them, and you know how to react to problems. With the scenario planning and the continuous feedback loops, your team become more proactive. So not the firefighting from the beginning, you're more proactive. Again, three examples from the slide. When you see maybe an additional order in the scenario mode, you have the possibility that, for example, a sales guy likes to know what delivery date he can say to the customer for a potential new order. So you can check this with the with Scanplan in the scenario mode. Make or buy decisions. Yeah, you can change in our system the material data, so you can simulate what happened when you buy the material or you produce the material by yourself. What happened to your resource utilization, for example. And the third one, for example, is resource bottlenecks. Yeah, when you imagine you have a resource that is totally overloaded at the moment, but you know, okay, I have to do a maintenance on it. So what is the best moment? How does this affect the orders? They are already scheduled, planned on this machine, but you have to do the maintenance. But you can decide, okay, what is the best moment for that? So, and now I like to jump into my live system. So do you see now the browser, Gunplan?
Yes, we can see, Raik.
Yeah, perfect. So because I'm very good in time, so then I can explain a little bit more. So at the beginning, what do you see here? Yeah, you see our Gunplan software. It's the APS solution of the iTAC MOM suite, and we right now in the heart of our system, it's the Gantt chart. Yeah, on the left side, you see the resources here. Yeah, we have some filling. Again, give me 1 second. I zoom a little bit. Oh, that was the button I looked for. Okay, so on the left side, you see the resources. We see some machines. We see here 2 workers. It's a very, very small scenario, and we have some tools. So these resources are, all of them are limited. Yeah, you see in the Gantt chart, all the white spaces, for example, is free time. So we see, okay, our manufacturing zone don't have a shift model, for example. Here in the filling machines and so on, we see a shift model because we see, okay, on Saturday and Sunday, there is no available time. But if I zoom into, for example, Friday, we see, okay, the machine is available from 6 to 11, 6 in the morning, 11 in the evening. And it's just possible to schedule orders in the free time. Yeah? So for operators, they don't like to work 12 hours, 18 hours a day. So here we have another shift model because they are just available until 2:30. They begin in the morning and they end up at 2 in the afternoon. And they have a lunch break here, lunch break, and then breakfast break, for example. So you can add all of these information in the MES, and we have it directly in our system. And this is very important for the planning, that we get a realistic outcome of the system. Because when I have a planning with an unlimited capacity, then the system says here, okay, produce everything on Thursday, but that's not possible, for example. So, and now let's come to one of my examples. We go to a different color scheme. You see here a lot of colored bars, random colored bars. Every bar here is an operation of an order, for example. If I go here, you see, okay, we have an order number here. We have setup and processing activities. I can explain when we have enough time. And you get a little bit information about the actual status. Yeah? Now we see, okay, this order is delayed by 14 hours. So, and now we see if I change my random color to maybe one of the nicest color schemes, it's a traffic light. Now I see, okay, everything what's green is fine. The yellow, orange is on time, so it's near to the due date. So they are not late, but they are far before the due date. And the red ones, they are not good. So, and now we see, okay, we have a lot of red ones here. So now we can decide, okay, what's happened when we have here, for example, in the assembly area. Here we have a lot of green, then yellow, and here red one. So now we can try, okay, what changed when we, for example, do an extra shift on Saturday. Give me 1 second, I will share again directly the browser because you don't see the bottom line here. Yeah, right now we see here we have 25 orders early, 6 on time, and 11 are late. So now we go to our scenario mode. I start them, and now I'm in a copy of my real system. So, and now I can do, for example, here I go to the assembly area and add an exception for Saturday. So I'd say, okay, on Saturday, maybe from 6 here, from 6 to Saturday, and we take 22. I add an exception maybe for work. So when I now apply this, now we see here we have a now free capacity. So now I'm able to move that manually, for example, to this free space, or I can do this automatically. So when I go here, now I'm in the scenario mode and I create in the scenario mode a manual planning, for example. So because then we can easily compare the production plan to the manual result. So when I go here to the assembly machine, now we see here, okay, we have a gap, we have free capacity. I click on the resource, go to, where is it, close gaps, click on do it for everything, and when I click here, now we see, okay, the free capacity is used. And when we go here to this chart, now we see here that's our production plan. We know, okay, we have 11 late orders, and after rescheduling, okay, we have just 10 late orders. So on time 25, and on early 25, on time 6, and so on. And now I can add maybe another free space and can repeat this by if I want. And then we can check, okay, is it with these changes, do we have the possibility to reduce our late orders? It's one of the possibilities. Let me explain you something with the materials, for example. So I close this scenario file, so I'm able to maybe to save this, and then I can open it again and present them to a manager or someone else if I want to explain, okay, the extra shift helps us to reduce the delayed orders, one possibility. So now I change this and we go back to our production planning and I change the color scheme to material. So now all of the orders they have the same material gets the same color, for example. And give me 1 second, I have to check one thing. Okay, looks nice. And now we see, okay, we have here, for example, the refill red, for example. So we need red color. Here we have blue color. Here we have black color, and so on. So, okay. And we see here this little truck. We know, okay, we have here a delayed purchase order, for example, because I said the purchase order arrived at midnight, but it's not in the stock already. That's the reason for this icon. But what happens when one of these orders is delayed, for example? Because right now, as you can see here, in the purchase orders, we see, okay, all of them have the delivery date yesterday, Monday in the night. But what happened when I changed this? So now we see, okay, here we have planned the red refill. So what happened when I changed this maybe to Monday? So we get the information out of the ERP system that this purchase order is delayed, for example, by 1 week. And I changed this. But let's go to the scenario mode first. I go here inside, go to the purchase order and set. So we have to check which one is the red one. That's the black one. Here's the red one. So, and now I change this. Normally I get this information maybe from the ERP system, so I don't have to add this manually, and I change it by 1 week. So, and the result is very nice because I go in my system and now I get here an information, okay, the provision time of the purchase order is after the scheduled start of the activity. So that's a problem right now. So, but I'm in my production plan. So that's the result of the last scheduling. But I get information, okay, it's not possible normally because you have a lack of material. And now I can do maybe an automatic planning. I do this. And when you see now, red is a little bit behind and the gaps are filled with the black one. So we can have a look. Give me a second here. We can change this. Take a little bit here. Here we can, here we have our production plan. So the base of our scenario. And with the planning, we get the result. So, and what's funny, for our delivery, it's good that the red order is not on time because we have one operation less late than in the normal plan, for example. Here we have 10, and here in the production plan we had 11. So, and so you can check very fast what's happened when something is changing. So it's as well possible maybe to add here, because we have the time, I say, okay, Aaron is ill for 2 weeks, for example. So we go in our production plan and I say, okay, Aaron is sick. And yeah, I have to, give me 1 second to discard the result before. And now I can change his calendar and say, okay, Aaron is sick for the next 3 weeks, for example. Say he is ill. So we get the information maybe from the MES or from the HR department, and they maintain it in the ERP system. Here we get directly the feedback, okay, we have an over allocation of Aaron. So because he is not available normally, but he has scheduled orders. And what we see is that all of the white spaces is gone and he is available from Wednesday, 28th of May. And now I do my scheduling again, for example, and then we see, okay, Aaron is no longer used, but we have more late orders for sure, because Marley Ziegler has to do all of the work alone, without Aaron. So that's our very, very strong scenario mode. And as well, in the planning, so now I leave the scenario mode. In the planning, I have the same possibilities. I can do an automatic planning if I want, and then I have the possibility maybe to change the orders of the operation. So I'm very flexible. But as you know, we have delayed the delivery here. Yeah, so it's not possible to move the red before Monday because the material is not available. And now I have done a lot of cars in my system, and when I like to get it repaired, I click on both machines, say repair my schedule, and everything is fine. So and now the system tries to hold a lot of the orders that I have created manually, stable on the machine. So I've decided to change here from black to blue, and the system say, okay, it's your manual decision. I try to fix your violations in the plan, but you decided that blue is here better on the fitting machine 100, for example. Okay, so now I will end my presentation, and hopefully you have some questions for me.
Yes, Raik, thank you. First of all, I will quickly share the presentation again. All right. Yeah, thank you. It was also interesting that you showed us the different scenarios in the life system. And we do have a lot of questions right now. So you can also yourself see it in the Q&A session if you open it. Yes. Let's start with the first one regarding to you. The first one is it seems to me that a lot has to be set manually for the analyses in scenario mode. Is there also some kind of automation for data maintenance?
Unfortunately not, because because every customer is different and every customer likes to look for different scenarios in the scenario mode. So there's no possibility, for example, to whatever add one additional machine to every routing, for example, because every routing can be different. So maybe you have 10 injection molding machines, but you can produce 5 products on 5 different machines. So it's not possible to get a very flexible data interface for that. So at the moment, unfortunately not.
Okay, thank you. Second question is, now that we only talked about MES and APS, what role does the ERP system play in the interaction between the two systems?
So that's right. So normally in the data flow, the MES gets the information from the ERP system. So our data source is for 100% the MES. So we are normally only connected to the MES, but the MES gets the information out of the ERP system. So the MRP normally is done in the ERP system. So the ERP creates the orders, purchase orders, and so on. But the information is transferred to the MES, and so the information is available in Gunplan. So it's a very important role. But in the resilience, in the very short time flexibility to know, okay, in real time there is a problem on the machine, we get the information not from the ERP system, we get the information from the iTAC MES.
Thank you. One more question. Can planned orders also be scheduled in APS? If so, how does APS handle the changeover from a planned order to a released production order?
Okay. Yes, that's possible. And here's important. That is one important thing. An MES don't like a planned order because the planned order will be deleted by the MRP again and again and will be created with a new number with every MRP run. So for that, we have a bypass to the ERP system. So the 100% data source MES is not correct in this case. So we get the planned order from the ERP system directly in the APS, and we mix both of them. So we have the production orders and the planned orders in one system. And when a planned order is changed to a production order via the MRP, for example, or via manual releasing a production order, the production order knows which planned order is the base, and we have a solution for that we know, okay, now we can delete the planned order and use instead the production order. So that's possible, and we have done this at some customers already in combination with iTAC.
All right. Then let's cover also the next question. At the beginning, it was shown that DUALIS can also serve different markets. If we have both injection molding production and assembly or metal processing in the company, can one and the same system be used, or are different templates required?
No, it's the same system. So because Gunplan is very flexible in how you can use it. So we have no one specific area where we use Gunplan. So we are in injection molding, electronics, mechanical, work, and so on. So Gunplan is very flexible how you can use it. So it's possible to do all of them in one planning model. As you can see here, we have some filling machines. We have an injection molding machine, just a very small demo. And you see here we have a manufacturing zone. And all of these machines can have different optimization goals, for example. Injection molding, there's the goal to reduce the tool changes, for example. And maybe on a painting cabin, you like to reduce the color changes, and you like to have a setup matrix from white to dark, for example. That's possible.
Mm-hmm. Thank you. We still got time for a few more questions. What benefits would a manufacturer get from the Gunplan software if an MES solution is not available? Does it still make sense for an APS system to be placed?
Yes, for sure. What is important for us? So as I explained with ERP, MES, and APS as a data flow, nearly all of the information has its origin in the ERP system: orders, routings, bill of materials, purchase orders, and so on. And for sure, it's possible to connect the APS directly to an ERP system. That's possible. But then we have to speak about how do we get the confirmations of the orders. So because when you only use an ERP system, normally the confirmation is not done in real time or very often in a day, maybe just once a day, for example. And then you don't have this 100% transparency every time in the system, because when we only get the confirmation at the end of the shift, for example, so we don't know, is this order started, is it finished, or whatever. But it's possible to connect the APS directly to an ERP system.
Mm-hmm. Okay. How is the planning horizon defined in APS? Is there a differentiation between operational planning and tactical planning? And what is the minimum and maximum planning period?
There is no minimum and maximum planning period, because you can decide it. Right now in my demonstration, you see, okay, I have just 4 months here, 3 months, 1, 2, 3, 5 months. But we can say, okay, the planning horizon is the next 3 years. But you have to think about it's a detailed scheduling system. So normally the strength is to get right sequences on the machines. And you have to speak about the tactical planning. So what is the goal? Do you like to answer the question, is it more efficient to move a whole product line, for example, from one plant to another plant? That's possible with Gunplan, but not in the same detail level. So normally we have a business logic before our planning system, because it's very flexible. So we get the detailed information out of the ERP system, and we do the data a little bit more rough for rougher planning. So maybe we don't schedule on the specific machine. So we maybe schedule on a machine group, work center group, for example. We don't maybe schedule with the unique worker. So we schedule with worker groups, for example. So we do a rougher planning, because the planning horizon is more longer, because our system had no functionality to say, okay, I like to have the detailed scheduling just for the next two weeks, and then do a rough scheduling. It's not in the same system, but it's the same tool. So that's possible, but we have to speak about what are the requirements for that in detail.
All right. Okay. I will pick one short question, and the other ones that are still open, we're gonna answer afterwards. Are there limits to the APS? For example, a number of machines or number of orders or other limits?
There's no limit at machines, because if you have a lot of machines, it's good for us, because the license prices are high. So that's good. And orders as well, there's no limit, so no hot limit. But when we speak about 100, 200,000 of orders, it takes longer to calculate everything. But the system will find the solution in maybe in shorter time or in longer time. Yeah. So, but normally we schedule about thousands of orders in under 1 or 2 minutes. So when we have 10,000 orders, it takes maybe 10 minutes to schedule them. But it depends on the optimization goals on the different machines.
All right. Okay. Okay, I guess this is it. Like I said, we're gonna answer all of the questions afterwards. So thank you, Raik, first of all, for your presentation.
Welcome.
And we are gonna continue with our next presentation and welcome back Sebastian. And he is gonna talk about, oh, that's one slide too far. He's gonna show us how to manage failures in production. So Sebastian, welcome back, and the stage is yours.
Okay, thank you. Hello once again to people who joined to us in meantime. My name is Sebastian Pesch. I'm from Accevo, and I try to tell you a little bit more about the very powerful tool to real-time failure management. We call them CMMS, and I try to explain how it's working and what benefit can give us the system. Okay, this is some of the stories from our customer facility. That means they have problem with some cases. I should say challenges. So they have challenges with overview of all of work, because sometimes the maintenance department can be very big, sometimes the factory can be very big, and it's difficult to find the employees on the production and what they are doing right now. So in this case, this is the challenge, one of the challenge from customer. Of course, cost reduction, because this is always very important. The communication inside the facility between inside the maintenance department and between the department, like maintenance department and production department. I spoke with one of the customer, and he told me they used 3 different channels via WhatsApp, via text message, and via email. So in this case, the communication can be very difficult, and we try to solve this problem, this challenge very easy. Of course, slow undone reaction. Undone means breakdown on your production. We call them undone. So in this case, I will use the undone. Unexpected failures, and try to not doing this on the production. Forgetting about the preventive maintenance, what is very important. We don't like to remember about we cannot remember about everything, because there's a lot of things, mainly on the production, on the line, when we have a lot of machines. So we can skip it or put it to our system, and he will be send us notification about it. I will tell you a little bit more about it. Paper documentation, data in different place. This point is connected, because some of the reports we have on the paper, some files, some information are on email, some are in Excel. So in this case, we want to have everything in one place, because we want to have full history of maintenance or of undone of every single machine. But if our customer make an audit, then we can very easily find every important documentation. And loss of technician knowledge due to staff change. So this is very important to have the knowledge for every maintenance team members, and not only, of course. Okay, first of all, we have inside the system the dashboard, which show us every important thing, like upcoming, ongoing, on recently finished orders. For example, we can focus on KPIs like downtime or MTBF, and we can check it what's happening on current shift. Is there any really hot topic to close by maintenance department? So in this case, we have quick summary of all of the work reaction on late orders, because this is typical in our customer facility, and check the orders without reaction, like, for example, preventive maintenance. KPIs are very important for every customer, so we can compare the KPIs and the cost, for example, between the similar lines, similar buildings, between the machine. If we have the two similar machine but in different age, then we compare. Maybe it's good opportunity to make to change one of the machine, because the cost of the maintenance of one of it can be very high. Higher than the second one, the newest. So in this case, we can create a dashboard with information and the most important KPIs, and compare lines, buildings, different facilities, and of course we can monitoring the trend, because then we can create new action and new steps. But before we start to create the add-ons, we need to build our factory structure. In this case, we have different way. I mean, our customer have a different way, because sometimes they create just the line. Some of the customer go much deeper and create every single machine on the line. Some of the customer even make a very important part of the machine, like engine, like I don't know, PLC or HMI screen, for example. So first we create the factory structure, and then we can if we put more data here, then we have more information on the next steps in our reports, in our performance dashboards, and we can of course monitoring the cost deeper to every single machine if it's necessary. Of course, in CMMS we can create the maintenance orders, but it can be add-on, like breakdowns, but it can be not only add-ons. We can create the idea, we can create the calibration, and preventive maintenance. I will tell you a little bit more about it, and then we have everything, all data in one place. Okay. When we have a lot of information, one of our customer have, after 7 months of using the system, around 12,000 cases inside the system. So the maintenance department can be very big, and there can be a lot of information. To summarize the information, we can create the separate dashboard, the screen for the maintenance department. We recommend to our customer to put the big TV screen inside the maintenance room. Then they have a very easy access to today job, or something hot topic, like I said, or any other cases open or late cases which we need to make a right now, because it's over time very much. So in this case, we can create the customized screen for our customer, and depends of the customer. Sometimes we show if the customer have team dedicated for a single line or single building, then they can see only this area, or they can see all the factory. Depends of the customer, like I said. So in this case, it's fully customized for the customer needs. Like I said, nobody can remember about everything. So we try to help our customer to forget because system will be remember about it. Forget about the preventive maintenance, preventive calendar. Inside the system, we have a preventive calendar with every single action dedicated for every single machine. Because on the line, maybe it's not very big, but on the line you have your resources, that means your machine, and we can create the preventive calendar, preventive action for every single machine, and we will have on the timeline see when the action should be should be do, or if we are if we forget about some of the action, then we can check what's happening because we have some other very important topic and we need to switch the preventive maintenance on the later. But in this case, if you have that calendar, you won't forget about any periodic inspection, any periodic calibration, or any other action. And you have, like I said, it's very helpful for the our customer when they have the audit audit inside the factory. It's very easy to show, okay, we have planned on the preventive maintenance in the future, in the future, but this is the information about the periodic preventive maintenance from the past, for example. Of course, what is the, in our opinion, big advantage of our system? We can create the separate reports, separate, maybe not reports, separate forms to dedicated action for the maintenance department. I mean, if we have a calibration, we don't want to forget about any preventive calibration for the machine, for example, or preventive maintenance. We want to create we can create the checklist for the maintenance team, and they don't forget about any single step. How we do it? We do it in paperless. This is our separate module. First of all, we create the flow because we want to know what will be the next step or what should be the next step if something is wrong. If we create the flow, of course, we do it together with customer. If we create the flow, if we have already flow, then we go to create the templates. The templates can be dedicated for every machine, every line, every action. So in this case, we will have every single step, and we don't forget about any steps which can be very important in the future because we want to use our machine. They shouldn't stop, and we don't need to repair it. If we create the templates, then we create the forms. This is the example of the forms where we have information about the steps. So very easy technical team can check, okay, I make all of the steps. Every person which have access to our system need to log into the system. So we exactly know who is responsible for this action, who is responsible for this step. And in this case, the technician need to confirm the steps. So in the future, we can check, okay, everything was okay with this action, everything was okay with this report, and we have historical data inside the system. So we have a plan time need to each task. So this is helpful for our customer. We have very easy show the list to do, so we don't skip any step, like I said. Inside the CMMS system, we can create the warehouse. We can create the one warehouse, or we can create the few warehouse dedicated for different location inside the factory. We can very deeply describe the every single warehouse. I mean, we can create the warehouse for the building with description of the racks, of the shelves. If we have a warehouse, then we have parts in this warehouse, so we can create we monitoring the stocks on and location of items. We can make create order list to purchase department, automatically send to them the necessary parts to order on the production, because we have information about the limits. If we cross the limits on in our warehouse with some critical limits for some parts, then automatically we have a notification inside the system, and we send information to the purchasing department. We need 10 10 pieces of this part because we are under the limit. We can make, of course, the inventory inside the system. So we can create the labels, we can print the labels, we can, if we have a mobile terminals, then we can scan the barcodes, for example, and automatically put the parts, and it can be connected to the to our order or to machine, and it's possible inside the system. We can create the calendar for employees because, like I said, sometimes the maintenance team can be very big, and if they are on the production, it's difficult to find them. So we can check where are our employees today, for example. We can check what they are doing right now. We can manage on the future the team and plan the absence. If some of the employees will have a holiday, then we can switch the guy responsible for the preventive maintenance, for example, and put this order to other person. And it's helpful because we have a make sure the right stuff availability and imported data for HR system. We can monitoring our components and tools on the production. So if we know our injection molding machine need to be repaired, need to change the tool in every 10,000 steps on the production, then we can put it to the system, and the system create automatically the information. Okay, we have 89% of the cycle from one of the machine, and we need to create the of course the system can do it automatically, can create the task for the maintenance department in next week. Probably we need to change the tool on the injection molding number 5 because the tool need the regeneration, for example. In this case, customer not miss any replacement of tool. It's much easier to planning the production, and of course we can cost save because we don't destroy any tool if because we forget about the regeneration of tools. So in this case it's a helpful solution. Inside the system, this is another thing which we don't need to have in mind. I mean, the maintenance manager don't need to have it in mind. So we create the employee skills, manage the skills of employees. We create the permission on the factory, like working safety, like permission on the using forklifts, for example. We create the team of the maintenance team. It can be people from customer factory, but it can be people from outside company, because sometimes we need the service guy from, I don't know, KUKA robots, for example. So in this case we can create that resources. And to this people, to this person, we sign the permission, the skills. It can be permission on, like I said, forklift, for example, which is important, which employee can use per 2 years. He after every 2 years he need to make another, I don't know, test, for example. But it can be skills like, okay, this guy knows very well this injection molding machine because he always repair it. So in this case it's easier to sign him that add-on from this machine. We don't need to remember, the system give us reminder when the skill will not be valid, and manage the skill for external companies, like I said. Inside the system, we can put all of the attachments. It can be PDF reports, it can be screen, it can be photo, it can be movie. It can be helpful because we have a data inside the one place, like I said, and it can be helpful because we can check very easy. I mean, the person responsible for some action on the machine can check very easy in history of the machine. Okay, last time we have trouble with this part of the machine. Maybe in this action will be the same. So we don't have problem with when somebody left the company, then we have a history of the machine and we can use his knowledge because he knows the machine better, but the knowledge is still inside the company. And like I said, we can put the movie, the PDF, and any other files, and we have everything in one place. And it's of course very helpful when we have again audit from the customer side. We can show him this is all the history of documentation for every single machine, for every single employee. So it's easy to answer on every customer question. We have documentation in one place, what is very important for our customer, and not only, and attach any document for maintenance usage in the future. What benefits we have to implement the system? I told you about more or less about everything, but of course we have all data in one place. We have reports faults quickly with our paperless maintenance system. So like I said, we can create the single checklist dedicated for every action, every machine, every line. We can very easy planning our inspection, our resources, what's going on actual machine, cycle time. We have reminders of schedule work, timely inspection, because we don't remember it. We don't want to remember about the system. Need to remember about that action. Better control on repair time because we have a big performance panel. We can check the MTTF, MTBF, and all of information, all important KPIs dedicated for maintenance department. Increase machine availability and performance indicators. Tracking machine maintenance cost. Like I said, we can compare line to line, machine to machine, and show very easy to our management. Okay, we need a new injection molding machine because the old one is we have very big trouble with it, and the cost is very high, and preventive failures for occurring. In this case, when our customer implement the system to his facility, this is the most important thing. We can reducing production downtime over 65%. Increasing mean time to failure MTTF 25%, reducing mean time to repair because we remember about the preventive maintenance. We remember about the everyday, I don't know, oiling, for example, machine, about 55%, and reducing the total number of repairs about around the 10% because like I said, we remember about the preventive and not skip any preventive on our production. Okay, thank you for your attention about the CMMS. If you have any question to this system, it's a good moment to ask about it.
All right, thank you, Sebastian, about showing us insights into your CMMS. We do have a few questions. Let me check the Q&A button. The first question would be for you. Are the undone boards shown available as standard, and can customers customize them independently?
Yeah, of course, the system is customized for every customer. I mean, every customer, like I said, we call the add-on, for example. Some customer call the downtime. Any other? So every implementation, on every implementation, we sit together with the customer and ask him about the names, about every details, and then we make a customization for him for his system, because he want to be he need to be easy to use for the maintenance team, and not only.
Then a second question would be, is it possible to connect CMMS with external systems like ERP and MES?
Yeah, of course, it's a very good question. In this case, yes, I need to answer yes, it's possible. If we have connection with MES system, then we have information direct from the machine. I mean, when the operator called the technician, it's possible from operator panel, then automatically we create the order for the maintenance team. And we know very well what's happening. We can read automatically because we have two ways. I mean, if we have deep connection with the machine, then the failures from the machine can be automated, sent to the CMMS. And if we don't have, the machine is very old and we don't have possibility to do deep connection with PLC, for example, on the machine, then the operator can call the maintenance and send them notification, the alert about some trouble, about the calibration of the machine. So in this case, it's very possible with, of course, MES system. And of course, it's possible with ERP system, because then we have information, for example, about the orders dedicated for our production. And then we can compare it with the preventive maintenance in our calendar, and then we can check, okay, in this moment we have a preventive maintenance. We can call to our sales department, for example, and ask, can we skip about 2, 3, 5 hours some order on the production, because we need to make a preventive maintenance on the machine.
Then we have a very detailed question. By the way, you can also see them yourself in the Q&A session. You said that on the second slide, react on late orders. That was a key benefit. And where does the target date for the order come from? So do they come? Do they also have to be planned in the APS or with the APS?
Good question. I need to look on my second screen, second slide. Sorry. Give me just a second on the second slide.
You can share again if you want.
That's mean is it possible? Yes, I think it's possible. Maybe a better question for the DUALIS, because I think, in my opinion, it's possible to create the orders for the maintenance. I think it's possible, but of course we can do it inside our system. I'm almost sure we can make an interface between both systems. So I hope the customer wants to see in one system information about the preventive maintenance and want to planning their production. So I think, in my opinion, it's possible, but we can compare it with our technical team and colleagues from DUALIS, and then answer very, very precisely on this question.
All right, then we will take that question also with us. One last question. Can CMMS systems be used for more than just production machinery?
Okay. Yeah, it's very important. I forget about it, because a lot of customers thinking about the CMMS and connected it very strong with the production machine and lines and all of the stuff. But of course, yes, we can use the CMMS system for whole buildings, for the gates inside our company, about the air conditions. I mean, one time per year we need to change the filter inside the air condition because we breathe this air. So in this case, we can use the CMMS system for every single resources inside the company, and not only on the production, inside the office, out of the buildings, everything can be in one place. So we can use it, and we don't need to remember about the preventive for the for the single resources.
All right. Okay. Let me check if there are more questions. Right now, no. Just for everyone who's new also in the session, you can ask questions via the Q&A button. And if we have the time after each session, we calculated like 5 minutes or 10 minutes, then we can answer the questions with our speakers over here. If we don't have the time, we will come back to you later and answer the questions for you. Okay, thank you, Sebastian. I think we are done with your topic, and now we will continue with compliance and interlocking. And Andreas is presenting this for us. Andreas, if you're here, you can share your screen if you want, and then start with your presentation.
Yeah, I can hear you. And yeah, thank you, Alina, and good afternoon, ladies and gentlemen. And yeah, I want to talk. Oh, do you see the screen, or I have to share the screen?
You can share it yourself then, because
Okay,
I'm sharing right
good.
now.
And one moment. So, okay. So now it should work. No.
Yes.
Okay, so
Yes.
here we are. Yeah, good afternoon once again. And yeah, I want to talk about ensuring compliance with interlocking by using interlocking and the benefits which are deriving from this. And yeah, let's have a short view on the agenda. What kind of risks we are typically facing if you're not compliant with specifications. It's maybe interesting. I will here present an example, and I will talk about the integrated approach when you are using a MOM system or MES system for ensuring compliance, and also the different types of interlocking, because there are various requirements within the production which needs to be covered to be compliant. And finally, an example of an e-motor assembly. Okay. Yeah, when we talk about risk with compliance, I'm using here a little bit older example, but it explains in a very good manner how big a risk can be. So as 991 GT3 has been launched some years ago, they had serious issue with road bolt, and so finally they had to replace all the engines from these cars, and in total 785 cars has been affected at the point of time, and they have to be all collected by the Porsche company. And for sure, it's not all the time in that dramatic way as you see it here, but you can certainly assess your own risk, what you're having in your production by producing your products. And that's your task. Nobody can do that for you. You have to do your own assessment. And yeah, because there's always a risk. I want to show how that risk could be managed. I guess a lot of companies in the past try to manage this with using different papers. So that means you have specification papers to fill in by the workers and so on. But for sure, that's no more a solution in 2025. So with paper, it's no more a good idea, I guess. And therefore, let's come to the MES or MOM approach. Let's start here with an overview when we talk about the MES connectivity. In the overall integration concept, you have usually an ERP system in place where you get the relevant data. So that means specification is also the bill of material, it's a work plan, it's a recipe, and some specific attributes you want to use to achieve the production in a compliant manner. And those data needs to be downloaded in the MES because ERP system is most of the time not able to interface directly with the machines. Therefore, the master data and the specification data to ensure compliance has to be downloaded into the MES, in our case, into the iTAC norm suite. And then you must be able to map these detailed requirements down into the machine integration. Though, and it doesn't matter if you're using a PLC, if you have an operator guidance, so then it's needed to have a workflow which is including your typical specification for your product, also in an operator client, or it could be also a direct integration in a line controller. So I don't want to talk so much about the technology, how does it work with API, but I will give you some examples then later on. So when we think about, we have from these APIs more than 500 of these functionalities. This data needs to be mapped, and if we have a look on the integration map or the connectivity map. So first of all, as mentioned, integration to ERP must be done. So those data can be mapped into transfer tables within the iTAC norm suite later on a little bit more. And then we have also to integrate the shop floor. Therefore, we have our standard API service. And the big benefit here is that we can exactly adapt the software regarding to your production process, because we have these 500 standard functions which can be combined and can express your process flows. So then it's necessary that it's not a one-way communication. API means always to have a bidirectional communication, and bidirectional communication enables at the same time a real-time control, because we can make sure that the thing's going in the right direction by comparing data. Tailor-made user interfaces for sure. The HMI client release ready download scalable. That's also an additional benefit, but that's not the main point. The main point is that you can use here a standard solution and at the same time a flexible tool set for doing this integration. And so it's possible to mapping the process requirements that you do not yet know today, and that is the biggest benefit. But how does it help you in reality? Maybe one step back to the SAP integration. In reality, you have SAP or any other ERP system in place, and you have to integrate it into an MES in the iTAC norm suite. And therefore, we have a specific adapter to. If you talk about SAP, though we can talk iTalk, RFCs, BAPIs, and OData, so the different technologies. And by using these adapters and this technology, we can transport a bill of material, work order with work plan, recipes, attributes, you name it. And those data end up in a transfer table when they are mapped, and from the transfer table, we are moving it with a second adapter, an ERP service adapter, into the working tables of the iTAC norm suite. And other way around, we can give feedback data back to the ERP. But for compliance, it's mainly important to get the specification data down into the system. So that's generally speaking the way. And the more interesting part is for sure the integration approach into your shop floor. And it doesn't matter if it's a highly automated process or manual driven process where you have worker screens. So coming back to the API functions, so these API functions you can compare it with Lego a little bit. You have a lot of these small questions where you get or where you answer or where you ask the system, please give me some information. And in our case, I made here a small example. Let's say we have this 500 functions, and you want to know which work order is activated on a line. Then you use the TR get station settings in our case. Or if you want to check, if you have a serialized production, if you want to check a serial number status, then you can use another function. Or you want to have the right recipe data that could be some specific assembly parameter for a screwing station or for a welding system or whatever. It doesn't matter. So specific data. And for sure, it's a mess if you want to integrate all of these functions one by one. So you would generate a huge amount of traffic, and so it's really then also difficult for the machine vendor to integrate this. Therefore, we invented years ago technology which we are calling custom functions. And when we talk about custom functions with this API, we are talking not about the new function channel. So it's an individual arrangement for your production process, for your production lines, because sometimes you want to make sure that you have the right material in place. On the next process, the right parameters. Then you want to check the operator qualifications, and so on, you name it. So there are various aspects which needs to be checked to be compliant with the specification. And the big advantage is that these custom functions are running on the application server. And the machine vendor has not only to deal with in and out, because we put them in a row or in a workflow. So that could be really complex, sometimes easy, sometimes complex. And at the end of the day, we have a custom template solution, because we are using such template definitions, a custom function, or directly, if it's an easy one, direct API. And so you have defined for your integration process finished blocks which can be called up. You have less complexity for the integration because the workflow itself is encapsulated, the functions, and for sure you can export these definitions and put it to the next server, the next instance. You can modify it. It's controlled by a revision, so you can also have an overview about the changes. And finally, you have less test implementation costs, and you have achieved a standardization for the plant integration. So plant integration means then at the same time to be compliant, because you can move all the data which has been originally specified in the ERP world or the PLM world down to your manufacturing process. Yeah, when we go further, let's give you an example. How does it work with an API? Because I'm not assuming that everybody in the audience is an IT expert, though I want to give a little bit more hands-on what an API means. So let's say we have here the iTAC MOM suite, then we have the MES integration layer. And those APIs will be called from the shop floor, let's say out of the machine. And here we have a certain station number, and the station is asking for the current status. And the system, the iTAC MOM suite, is answering that. And it says, okay, on this station, the BOM version 2 for the part number MG01 with work order number 42 is active. So then we know exactly what kind of product should be produced here. And then we have, or let's assume we have a serialized production. That's for sure another important thing or precondition to establish a compliant production. The next step here, we are asking for the serial number state to make sure that this serial number is allowed to enter this process step. And then we get again here with API function output, log state 0 says everything okay, or serial number state 0 says everything okay, and yeah, we can go forward here. And in the next step, we execute a test or assembly or whatever, and we are booking the state with the serial number and say, okay, everything has been executed on the station in a proper manner. So that shows we have always a bidirectional communication, and we are taking control of what's going on in the production. And this control is taken by the MOM system and no more by the PLC, because the PLC, if it's a PLC control process, is asking for the right content. And that's the big benefit here. Yeah, finally here the answer, everything okay. Status booking has been made in a proper manner. Okay, then if we talk about the different types of interlocking, I would like to give you an idea what kind of compliance management directions are available, because there are different challenges and also different names. So compliance is another word for, we call it also active traceability, because we are not only collecting data, we are making sure that we are doing in the right way, and we are following the specification when we are running the production. Or digital poka-yoke is also a term which will be used sometimes, or easily interlocking. So when we talk about compliance, we talk about active traceability, digital poka-yoke, and interlocking, and for sure there are other definitions in the market. The possibility of recording of all semi-finished and finished products produced with a unique serial number or batch number container with exact identification, verification, documentation in compliance with all specifications. That's what we are understanding when we meet compliance. And compliance can be done if you check work step. So let's assume you have a serial number based production. The product gets at the first step a unique ID. Then you can follow the whole process and you can check if the last step or previous step has been fulfilled in the right way and the serial number status passed. Think on optical inspections, because you cannot see on the product if an optional inspection really took place. So, but the system knows because it has the information via this API integration. Next thing would be for sure the material. So we are using unique materials bins as well in our system, and therefore it's only necessary to scan each material box or each material bin, the barcode on it, then we know exactly what kind of material is in, so with the part number, what kind of material lot, what is about the status of the container. Maybe it's locked for some quality reason. Opening time would be another thing. So if you have a dispenser and you have glue in it, so sometimes it's relevant that you control the time, because you can process this material only for 1 hour when it's opened. And expiration date and some other attributes can be used here. Tools are very relevant. So the correctness, the use of cycles, when it has been maintained last time, is it still the correct tool you want to use, or a test adapter or whatever. So that is also a part which needs to be registered on the station, and the definition is usually also made in the ERP system and aligned to the work step, so we can make sure that the right tools will be used as well. Next point would be then the process parameters itself, especially when we talk about hardware-software combinations. It's relevant to know that you have the right firmware, the right test software, and that you meet the right thresholds and you use the right revision. Repair loops would be another example. So which parts are allowed to repair, how often you can repair or replace a part. And it ends up with packaging. So you want to make sure that you are only pack parts which have the status pass into a shipping box. Timers in general can be executed, or attributes in general can be added to every data object and can be used for individual interlocking definitions. So that hopefully gives you an idea of what kind of compliance aspects could be managed with an MES system. And if we go now to an example, here I want to go a little bit across the complexity, why compliance management is necessary. And I picked up here an electric motor assembly as example. So typically you have in the motor, when we talk about the main components, you have a rotor, seen here, you have a stator, and you have a control unit, which is doing the management of the whole e-motor system. And so looking here at the rotor assembly, you see you have here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 steps generally, and you have different requirements. You are starting with serialization or batch tracking. You have maybe program specification for cleaning. You have recipe parameters here for the assembly of the magnets. You want to take care for the batch. You want to know which batch has been used. You're setting data per pocket here. By the glue dispenser, as mentioned before, you have the cure times. Then maybe a tempering oven you are entering. Then you want to know the temperature curve, which was effective at the point of time when you come through here with a rotor assembly. Another process step, don't want to talk about each process step here. You can imagine that you have to manage here a lot of compliant tasks. So same we have when we go here to this data assembly. So here we have to load the carrier and have to do the warming. Again, serialization and batch tracking. We have again recipes. We have again a temperature profile for tempering. And we have to do some inspections here, measuring again, and so on. Also, amount of data which come up here. And for sure, also the electronic control unit, where you have also a lot of production step, starting with lasering here of the unit number and the typical electronic production process. I will not jump here into every detail, just to give you an overview. You have SMT, then you have a pre-assembly, a final assembly, and then you have a testing area usually. So also a lot of steps which need to be executed. And to summarize it, so only from this data, we have roughly 1,500 to 200 measurements, a certain amount of raw materials, same for the rotor, and for the ECU, even more. So up to 8,000 measurements, and the complete E-unit itself has as well also measurement data and some additional raw materials. So in total, that means we have to manage up to 9,000 to 14,000 measurement data, and they need to be compliant with the specification. And also the right material has to be used. So that means up to 170 raw materials, and in total 10 to 20 units of sample assemblies, which has to be merged in the right way. And to show it now what the software can do, I will use this multi-level serialized production sheet, so to say, to explain it, what kind of data can be managed to make it more visible for you. Let's assume we start with the ECU, with the electronic control unit. You have for sure the part number on the semi-assembly and on the raw material, the PCB, the IC, the sensor. Then the products have a life cycle, so you're dealing with different versions. So you have a BOM version internal, but when you have a change on the BOM version, you maybe have also a change on the test program version. Then if you talk about the ECU, firmware comes into the game, so it needs to be flashed on the board. And finally, you have the firmware parameters. So that all these different data can be managed in the MES. And if you're assuming now we have a serial number here, and we know that we have set up a certain batch with a batch ABC and a date code when it has been produced, and we're looking forward to assembly, then we have here the rotor, also with a part number, also with a BOM version, and have a stator also with a serial number, and here also different version. So we can make sure that we have the full traceability, and we can check if it's allowed to build in a version 1 of the stator and version 2 of the rotor in a version 2 of the engine. So at the end of the day, we are doing setup check for compliance. We make sure that we have no blocked material used, that we have the correct test program, the right firmware, the correct production parameters, and going from the pre-assembly line, let's say from the electronic production to the final assembly, so that we can make sure that the status of all the serial numbers is passed. So that means they have done all checks in a proper manner, and then we can merge them into the final serial number. And another advantage would be then when we're thinking plant-wide, we make sure that we have not redundant unique IDs, and we can ensure that we are only produce functional versions, and that's the big benefit here. Yeah, we are almost at the end of the time, for only 25 minutes. Yeah, generally, when we put all together, so we get or we gain a certain amount of benefits here. So we have learned that we have a complete process control by mapping the entire production process in one solution, in one MES system, because we have all the master data, all the specification data from ERP, from PLM, or for wherever. And that is the base to do the compliance management with interlocking. And for sure, we have as an additional benefit, we have the full traceability, because we know exactly what parts has been used, what parameters has been used. And so we can really have the compliance with quality and product criteria specification. Not only process, also production compliance then is given, and for sure that's also the base for analytics tools, because if you want to get insights by data analytics tools, you have always to build up the relationship to the master data, to the work order, to the bill of material, and so on. And for sure, by having with every booking a timestamp, so you have as well the basis for an overview about your complete performance management in the production. Yeah, that was the overview or regarding compliance management by using an MES or MOM system and interlocking. And I would be glad to receive questions you may have. And I want to thank you for your kind attention.
Thank you, Andreas. I think this shows that compliance is not just a requirement, but also a competitive advantage. So thank you very much for this detailed presentation. I already checked our Q&A chat, and we do have some questions for you, and we still have time for some. So the first question would be, does compliance management help to manage product variants?
Yes, for sure, because when we assuming that we have for every product a unique ID, and imagine that we always have let's say a work order related bill of material, work order related work plan, and specific parameters, so we can really ensure that different variants will be produced with the right parts, with the right parameters, and so on. So I would say compliance management and interlocking with an MES is a precondition to achieve variance management in a high complex environment. Because when we look years back, you have only to manage a little amount of variance. And right now, everything is going to be more and more individual. And so there will be different applications will be made to products, and so that's a base for variant management as well.
All right. A second question for you would be in your overview, it's regarding the overview you showed about the multi-level serialized production. You showed that traceability is displayed across several product levels, including test program version, firmware version, etc. And are these information only documented in terms of traceability, or can it also be interlocked against such information to guarantee compliance actively?
Yeah, this data will be used to guarantee compliance because without or other way around, if you don't have this data, it's for sure only possible on a very high level, or let's say only on a work order level. On a work order level, you're never sure because you don't have the data in relation to the unique part or to the unique device. And therefore, it's absolutely in that way, in that manner.
Mm-hmm. We still have time for one last question for you. What are preconditions for establishing compliance management with interlocking?
Yeah, I guess that reflects as well into the last question. So when we follow the Industry 4.0 thinking, where we have to give every part, every device a unique ID. Though that means we have to have at least a batch number if you talk about a certain amount of products, or a serial number. Because only when we have such an identifier, we can make sure that the right data will be loaded for a process, like production parameters, or the right test program will be chosen. Because if you're just working with a work order, then you have it on a big amount. And if you don't have the physical identification by using a data matrix code or an RFID, it's going to be really difficult to convince the customer that you have everything under control, because it can happen everything if you don't identify your products. So batch and serial number would be, from my point of view, would be absolutely the base to establish compliance with interlocking.
Mm-hmm. All right. Then thank you again, Andreas. We are right on time for our next topic, which will be presented by Martin, and he will tell us what dark little secret the OEE KPI has. So let's wait and see. Stage is yours, Martin.
Great, thank you. Warm welcome to everybody again. Good afternoon, good morning, good evening, depending on where you might be joining us from. My name's just briefly Martin Strempel, obviously also from iTAC, like many of my colleagues today. Currently in the role of business development, specifically for the data analytics and data analytics suite that we have. And within that, we will see also specifically things like the iTAC asset analyzer. I've been working in software, at least software on the shop floor, for over 15 years now. A large part of that was spent actually in production management and production control. And that's really sort of where the idea of my presentation today originates. Something a lot of us take for granted in manufacturing. Something that we've built many of systems we've seen today, that's discussed numerous times around this topic. Something we showcase in reports, quoting meetings, and endlessly try to optimize. And that something is our OEE, our overall equipment effectiveness. And while this is a trusted metric and has been used for decades, it actually has some significant flaws. The secret that is costing manufacturers time and money and clarity. So today, a little bit more away from the technology. This is a little bit more philosophical in terms of a journey I'd like to go on with the audience today. But I would like us to rethink how we measure what truly matters in the production line and production facility. So the big question, let's start with the basics, right? OEE is simple. It is the availability, the performance, and the quality. And if we multiply these three factors together, you get a number That supposedly tells you how well your complete operation is performing. That sounds great. It's easy to understand. Managers love it. Operators know it. Consultants, they swear by it. But there's a catch. The simplicity hides all of the complexity. So it's kind of its own undoing in that sense. In today's factories, where nothing is simple anymore, that is actually becoming quite dangerous. So on today, I will kind of take you through this journey just to ask a couple of questions. So why OEE was once useful? Maybe what's changed? The hidden costs of keeping it alive? Kind of, are we fitting a square peg here into a round hole? And is that really still what the original purpose was of OEE? And then what happens when we chase this metric? And what if this metric is wrong? How can we shift from reporting performance to actually understanding what's going on in our operations? This is not about an incremental technological improvement. This is about a paradigm shift from machine metrics to actually understanding our systems, to cognition of what's going on. So I'm sure we are almost all aware, especially if we've been working in manufacturing for a little bit, that OEE was born in the 1960s in Japan as part of the total productive maintenance. The introduction at this time was all around lean production. And this was a time when factories were stable. They were running few products, and the lines were pretty much linear compared to today. One product, one cycle time, one machine at a time. In that world, OEE makes a lot of sense, right? And for years, this worked, especially in industries with high volume and low mix environments like automotive and consumer electronics. But here's the reality, as we all know, and we've actually seen many allusions to this today in many of the presentations that have come before me, right? We no longer live in that world. So modern factories are very, very different, right? We have seen today how high product variability affects all of our production, how it creates a huge number of additional decisions that we need to make. We've just seen how that affects traceability in the previous, traceability and compliance in the previous presentation. We have much, much shorter life cycles when it comes to products, right? Which means if there changes, these could always be substantial, and we need to think about how that might affect the OEE calculations. We have dynamic routing, we have changeovers, we have, even in the most modern factories today, software-defined workflows that change dynamically depending on situations and conditions in the factory, right? We have machines and humans now working side by side in the modern factory. And and if we really think about it, this is kind of why it's becoming so challenging for us to review OEE in a modern factory. And we're finding more and more that this is becoming more and more difficult to do, and that it's becoming very challenging for the OEE actually to represent something that is meaningful for us to actually make decisions on. So I want to make this a little bit personal. I'll share a true story from my side. At this point, this was for a larger manufacturer where every minute cost a fortune that we were standing still. And there were basically 3 shops. And our OEE at this point, this is quite a while back, but it was reflecting always green across the board. So we always had 90%. Perfect charts. And at that point, it kind of fits everybody into this mood. Okay, everything's running well, we're doing well, and things are going great. But that was not really what was brewing underneath, right? We were actually kind of blind to what was going on, because there's a lot of things that OEE wasn't telling us, and it wasn't showing at this point how fragile our system had become. So then things started to go wrong, right? We started to have small breakdowns, especially early on in the production, area, right? Mainly in the first shop. And the effect was that during the week, our buffers would start to drop. And just like that, suddenly we started missing target after target. We struggled to get to our volume at the end of the month. And our costs of keeping everything running was skyrocketing. So this is kind of what I really want to get down to. Although everything was green on the OEE side, we were actually in serious trouble. And the premise here for this discussion is, why was OEE not showing us more, actually showing us that we had a problem? So this is where the real pain lies, right? Not only does OEE have this blind spot, but to keep it running, we also have to heavily spend on system integration. We've just seen it also discussed a number of times today, right? We have huge costs. We have huge integration projects. We generally need custom rules if we want OEE to be transparent enough kind of to avoid the kind of previous scenario that I've just sent, which means we need to specialize it. We need to customize it almost for every scenario. Human intervention is often required just for the numbers to make sense, which makes it by default unreliable, especially across facilities or different plants and countries or continents. And this manual input actually also requires a lot of additional work, right? So we end up paying people to tune these formulas, people to adjust our integrations, we adjust our formulas, and so that we don't lose the transparency that we need for the metric to actually work, but all within this context of the factory becoming more flexible and more adaptable. This is becoming a greater and greater threat for factories as we go along, right? And this ought us to calculate a number that doesn't actually reflect how the system is truly behaving. So, what is the alternative, though, you might be asking? This is not just swapping one KPI for another. It's actually a cognitive shift that is happening in industry at the moment, right? And this is where I'm actually also really excited about what's going on, right? We've moving from measuring the machines to actually modeling the systems when it comes to performance management. We're going from snapshots of what's happening to actually an understanding of the continuous system and how the system interacts amongst each other. And we're going from rules to a system that can learn and adapt to these conditions. And this is where cognition kind of enters the picture, right? We're not really talking about artificial intelligence for the sake of a buzzword or for being but for it actually being adaptive and being able to explain with some sort of causality what is actually going on in our factory. So there's also what tools like the iTAC asset analyzer have been built for. Instead of us needing this full integration, this full picture from day one. I mean, you can imagine typically to measure OEE, there's a huge technological debt and integration cost that is needed right off the beginning, right? You have to integrate the machines, you have to interpret the machine states, you have to map these to, we saw even today, to the logics that you want to use to calculate your OEE. You probably have to verify it. And then once you've started that, this is kind of this iterative loop that you keep having to readapt the numbers to reflect what's really going on. The political part always enters the conversation, right? There's always somebody who feels that in an organization that OEE has been calculated incorrectly. And it just generally doesn't lead to a very clean, actually, calculation, even though it's supposed to be so simple for us to do, right? So instead of needing full integration from day one with this kind of new technology emerging based on our real-time streaming analytics, we can start with a minimal data connectivity. In the presentation today from Sebastian, we saw that by just monitoring how many units we've produced at each machine in our production line, we can already determine a huge idea and create a very good picture of what's going on in our production line, right? And that's where we start. Minimal machine data. You don't really need custom connectors from that point, right? And then you can start adding all of the additional details you need as you're going along for this kind of understanding and contextualization of what's happening in production. This is a huge area where obviously large language models are adding a huge amount of flexibility to us, right? We can basically feed these systems now unstructured data. Think of log files, think of reports. Not only like, you can also add voice notes, videos these days, everything to the system, and let the system interpret them, understand them, categorize this, and then add it into its idea of what's actually going on in your production line. And it builds this much bigger general understanding as it goes along of what's happening in your production line. So it learns how your line behaves, it learns how flow moves, it learns how the assets interact, and it can actually start then to explain the anomalies and not just flag them. Oh, sorry. And the nice thing is that it actually reduces, it's not more expensive than doing it the traditional way. Quite the opposite. It actually reduces your debt and your integration work by allowing you to start with what you already have and grow that over time. So let's not forget the human side, looking forward as well. More and more factories have this knowledge that doesn't live in dashboards alone, right? It lives in the people. We've also referred to it today in a couple of presentations, right? We have operators, line leaders, maintenance crews that all make very small decisions, but these all critical for actually a high running factory. In fact, it is actually said that the IP of a manufacturing house is not in the equipment and the products it produces, but in its people's understanding of how the processes run and keeping those maintained and keeping those the machines delivering the products as you require. So in that sense, why are we not focusing on that? Traditional systems ignore that, or at least I don't know if they ignore it so much as in the past it was too difficult for us to actually attempt to capture this data from these people, from these operators, from these leaders. And that's again where LLMs and large language models have become a huge, huge step forward right now. Modern ones, you can actually just upload voices, your voice recordings, your videos, your behaviors. It can introduce from your interaction cues with the dashboards that you're working with what you were doing, and not just what the machines are reporting, right? And this is how we capture what is now being coined in industry as tribal knowledge, right? And turn it into an institutional learning. So let's recap. Think of the human bodies. Senses are great, right? But what makes them intelligent isn't just senses, right? We have a nervous system that interprets what's going on, and we respond in real time. If you think of dashboards as sensors, kind of, I guess your OEE would be a thermometer. Modern systems like the asset analyzer are more like central nervous systems, right? Continuously inferring from the understanding and adapting. They don't need a full set of data up front, but they can work with uncertainty. They can work with partial views and still try to give meaningful insights. This is kind of what factories need at the moment, right? It's not a pretty report, but something that can link all of the causal effects it's seeing into an understandable and interpretable result, a type of brain. So I will go back to our original example. In that case, I said, and I mentioned, we've had OEE over 90% in all three shops, right? But what didn't help us is when the flow broke down, we didn't see what the buffers were, right? The buffers weren't being monitored. It was too expensive to monitor the buffers. And immediately that created a gap in our knowledge. So what was happening is that we were running production outside of the planned schedule. Another thing the OEE didn't pick up, because OEE was only being calculated according to the planned production times. Anything outside the OEE, any units produced were just ignored. So what was happening, in order to make sure that production ran smoothly, all of the buffers were being filled up on the weekend. And slowly, if something happened during the first 2 or 3 days of the week, all of those buffers would be depleted in 1 or 2 hours. And this would leave the system lean. And then the actual truth was that when we were running lean, we couldn't actually meet our takt time or cycle times. And we struggled for the rest of the week, which is why we would always have difficulty making our production targets at the end of the week. Our systems back then did not pick up on all of these problems. The question is, would modern tools do that? And I'm quite sure they do, right? They can handle and work with asymmetry and nonlinearity. Modern tools that have the available data would pick up that there was production happening outside of the planned production schedule. They would be able to detect bottlenecks. We discussed that if we have this approach where we don't need too much data to start, right? We can actually monitor a lot more of our assets than just the main ones or the main outputs of our shops, but can actually track individual machines. That would allow us to create a complete picture of the flow in the whole factory and not just see the individual outputs. So we would pick up on things like the skeleton crews working outside of the plan, and crucially, infer the causality, not just the correlation between all of these individual items. So, to close, we've been chasing performance through a static metric, right? We're paying a steep price to get, in terms of complexity and integration, to get this system up and running, and there's huge integration debt. The question I wanted to present here today is it maybe not time that we stop investing in an old metric that is almost 60 years old and start investing in understanding. We've seen that instead of measuring OEE, if we measure things like downtime, and if we can attach reasons to downtime, this is a much bigger tool for us to be able to actually analyze our environments and actually improve our production and performance over just monitoring OEE, right? Which sometimes just gives us the illusion of control while we could actually be bleeding huge amounts of money. Chasing OEE comes with massive costs, and it's a question if this should be done as pedantically in the future as we might be doing it today, right? We are unknowingly spending millions to keep OEE relevant, keep adopting it to our latest production. We keep having to customize integrations, manual inputs, data normalizations, logic layers, all just to produce a metric that actually doesn't even drive maybe potentially decisions or even drives us to make the wrong decisions. Factories are really spending real money to maintain a false sense of performance. And then factories are living systems. They need cognition, not calculation. The situation with high mixture and high volume and low volume is actually, and more variance is just going to keep increasing, right? We have systems that need to be able to infer, adapt, and explain, and not just statically calculate and measure these kind of performance things. We need to replace this kind of static dashboard concept with something that is responsive, aware, like downtime trackers, right? This approach is much leaner, much more flexible, and much more adaptable, and the technology is getting better and better. My postulate is that what we need in future is smart metrics for a smart factory. We should not be building our smart factories with a 60-year-old metric that doesn't even fit the picture of a modern factory anymore. So thank you for your attention. I hope I at least managed to create some thought and send you guys home with a new idea. And if we have the time, Alina, I would love to take any questions.
Yes, thank you, Martin. I think it gives everyone the opportunity to think on what to do in the future. So thank you for that. Thank you for the insights. We do have some question. I would start with the first one, which is, I think, a pretty valid question. So isn't OEE still useful, at least as a baseline indicator, even for modern factories? What do you think?
Absolutely. So I think OEE will remain that way, right? It's easy to start with. And we've also seen that a lot of the cases with MES, we need all of this functionality in the first place. We need the compliance, like Andreas just showed us. That's not something that will disappear any day. We need to be able to monitor and track and trace everything. So a lot of the time we have the building blocks that we need to get the OEE up and running. the question is as soon as you start needing massive integrations and custom logic per machine with endless kind of tweaks that just to get this static number out again, that doesn't always reflect what's really going on. At that point, I say, does it really make sense to keep a simple KPI like that running if it's costing you millions of euros as an IT project to do it in the first case?
Okay, that's good to know. A second question would be, in what ways can a future factory systems integrate human insights and tribal knowledge to enhance operational understanding and resilience?
Well, I think that is very much where the new tools that we kind of shown allow us to get much more visibility about how we're interacting with the machines as humans. I think we reflected briefly on also that the future does not lie in AI telling us how to steer your factories, but rather with us working together with AI to be more efficient at running production. And this is sort of kind of which forces you to build a whole kind of integration puzzle up front, right? And LLMs and using large language models and are allowing us to create structured data and out of this what would otherwise be classified as unstructured data, and have allowed this whole idea of adding the human content into the system, scalable and flexible in the future.
Mm-hmm. Thank you. A further question is, what are the advantages of using AI-supported tools like the iTAC Asset Analyzer that you mentioned over static KPI-based performance tracking systems?
Well, I think it's kind of the crux of the whole presentation. So at the end of the day, we, using the AI tool, will allow you to adapt flexibly to what is going on in your production line, and will give you full visibility potentially over things that are really happening and highlight what the information that you should be knowing. Whereas OEE might be a nice metric and static KPIs might be a nice metric to create a comparative result just to see when one is lying. But actually, because they are so simple, reflect a lot of the detail that you need to meaningfully do those comparisons. And AI and the ability to interpret all of the context into what's going on to the production was giving us an ability to do an objective comparison that goes beyond just measuring KPIs, right? It includes the reasons why the KPIs are different and what might actually be underneath the KPIs that are the root causes of that. So I think of KPIs as kind of more sort of the projection, kind of the shadow of the fire, of the people dancing in front of the fire on the rock cave wall, as opposed to actually looking at what the people are doing, And I think it'll be a big significant change for factories in the future, and using this technology to optimize production and software.
Mm-hmm. There's also one more interesting question over here. How can we address the OEE topic with old-fashioned, so to say, clients? So how can we tell them that this KPI is not the one they should be looking at?
Well, I think it's not that we need to throw out the OEE idea at all, right? We just need to reflect at what makes sense for us to still use OEE as, and for what. And from what point should we move away from OEE? If we are spending, like I said, if we're spending huge amounts of effort and money involved in getting the OEE and getting it to a point that everybody's happy, and we're catching and captivating all of the nuances that are required for us to use it as an objective KPI, if that is easy to do, then it makes sense to keep the OEE as a KPI. But as soon as we start moving into situations where those nuances and contextual inputs into the calculation change all the time, then we're moving into an area where flexible things like downtime tracking, where we're attaching causality to the reasons for the downtime through modern LLM infrastructure, is much more of benefit than spending that money on getting that square peg into that round hole.
Mm-hmm. I think we got time for one last question. You talk about systems that understand flow and context, but aren't those very hard to implement in real factories with legacy equipment?
I think that's again the beauty of doing it in a kind of adaptive way. One can, with this technology, you can start with the basics and keep building. The systems and the way they function are very different to maybe the way that your traditional MES works, right? Your traditional MES needs a whole preset list of requirements for it to actually be able to give you things like the OEE, to give you full tracker traceability. And that is why MES projects have such a long integration period up front. Tools like this, where we're looking at it being flexible and adaptive to the situation, can start with the most basic information and already feed you what the systems can interpret from that information back. And as you start adding more and more layers into the system, it's not a reintegration of the efforts, rather you adding more information into a system that can adapt to the information you're feeding it. So it keeps getting more detailed and keeps being able to give you a more refined answer to the questions you're asking, right?
Okay. So I guess we're done with the questions so far. If you have further questions or any other questions come up, you can always contact us. And then Martin is happy to share his ideas. So thank you, Martin, again for your presentation. We will continue with our next topic, and Julius from DUALIS is gonna show us how to use digital twins to design new manufacturing processes. So Julius, if you are there, you can share your screen and start your presentation.
Yes, thank you. So hopefully it works. Not yet. Do you see my screen?
Yes, we can see.
Perfect. Okay, yeah, let's start. So at first, thank you, Alina, for inviting me today. And yeah, my name is Julius Höhne, and I'm the sales manager of DUALIS, together with my colleague Evelyn Dietrich. I'm responsible for factory simulation and especially for the simulation tool Visual Components. Yes, and today I want to take you on the journey from concept to reality. And yeah, imagine you are able to design and test and optimize an entire product line even before you have built or bought just a single physical part. And that is what we do with Visual Components. And today I want to demonstrate a little bit how simulation tools like Visual Components works and how it allows you to visualize a product line from the very first idea to a digital shadow of an existing production line. At every start of the process, from developing a machine to having it running on the shop floor, there's always the idea. And with Visual Components, you are able to transform that idea into a working 3D layout, into a moving 3D drawing. That means you can quickly build complete factory setups, including feeders, conveyors, robots, machines, human workers, HEVs, and much more. And that brings you into the situation that you can do some tests like robot accessibility or capacity utilization of machines or HEVs or human resources. In a simulation, you can play with these properties and you can add a resource like a human, or you can add a HEV, or you can reduce it. And then you can find out what happens if you do this. And so you can do different tests and evaluate if a system works before you have to take a decision. And you also can create pictures and movies of your idea that helps you to present your idea to your colleagues or to your customers. And here you can see a digital model. It's a digital model of producing milk cartons and filling milk cartons. It's a milk carton packaging line. And you see here, you see the arrows. The light blue arrows here, they represent the material flow of the milk carton itself. Here in that machines, the milk cartons will be filled and closed, and then they come on the conveyor, move up to that point here, and here the milk cartons will be packed into a packaging carton. And the packaging carton comes from here. That will be represented by the red arrows. And here, like I said, the milk cartons comes into the packaging carton. And now you see there is a dependency between the milk and the transport carton. The transport carton can only move forwards once enough milk cartons have been arrived. And on the other hand, we need enough transport boxes to package all milk cartons and to avoid material jam on the conveyor. And then in the next step of this model, the packaging cartons will be closed. That happens here. And a robot will stack the transport cartons on a pallet, and the pallet will be packed with foil. Stacking on the pallet happens here, and here the whole pallet will be packed in foil. And in the end, the forklifter here that has the target or the task to fill the process with Euro pallets and bring the packed pallets back to a truck. And all this information about the goods flow and what needs to be available at which time is implemented in this simulation. So the simulation is a self-regulating model of a production line. So in this video, you can see how to create a digital model. We just placed the machines and the conveyors in the 3D world. And that is one benefit of a program like Visual Components. It has an e-catalog, which includes nearly 4,000 items, such as machines, conveyors, robots, safety fences, industrial trucks, human workers, or AGVs, and much more. And you just need to place the items in the 3D world, and the connection between the individual components, like from one conveyor to the next, that happens automatic. So no programming skills are required to create a simulation like this. And everything you see here is based on a plug-and-play solution that can be set up quickly and easily. So this makes it possible to turn an idea into a comprehensible model in a very short time. So these models can already be used for presentations internally within your company, or for sure with your customers, to demonstrate how the requested solution from your customer, how you want to solve this problem. And in addition to that you have this digital model, you not only have moving pictures like a visual representation of how the goods flow will be. The digital model allows us much more. It allows us to identify bottlenecks and draw conclusions about resource utilizations. We have analyzing tools, and we are able to extract detailed information over extended periods, like, let's say, like the robot status. How well is the robot utilized? And when do a storage area reaches full capacity, or is the forklift fast enough? Does the robot move fast enough? Do we have enough pallets available in the process? And we can report these KPIs like OEE and OLE, and we can already evaluate how long it takes from the moment a milk carton is filled to the moment it is packed and loaded onto a truck. And that gives us a perfect basis for optimization of the layout and in the end for decision making. And in my opinion, simulation tools are not just tools for engineers. Also, sales manager can use these tools to give clear, easy to understand presentations, and as a result, more transparent and convincing proposals, which helps you to argument how you will solve customers' problem. And once you finish the layout design, the feasibility checks, and the process validation, our digital model has accompanied us from the initial idea of a production line through internal presentations, through customer presentations, through the quotation phase, and all the way to the optimization of the overall concept. And now we know exactly where each element of the production line in the 3D world has to be and has to be placed, and what cycle time is required. We understand how many workers we need, how many forklifts or AGVs are needed, and we could even provide already an estimation of energy consumption. And once all these data leads into a final decision and our customer has placed the order, the digital model starts to transform into a digital shadow. Because after the customer has placed the order, the digital model helps the engineers to design the parts for the system, or the buyers to buy conveyors, and because everything is already defined. And once the parts are ordered and produced, and in the end, the machine and the production line is assembled to a physical production line, the PLC programmer can start to test the program. And beside this process, the PLC programmers start to develop the control software. And that based on the simulation on 3D drawings and circuit diagrams. And traditionally, these three PLC programs can be tested once the system is physically assembled. And with our digital model, we have a significant advantage because we can virtually test the program in advance before the physical setup begins. And this saves time, it reduces risks, and significantly improves the quality of the commissioning. Because here you see, before the PLC programmer works directly on the physical system, they can test their program by using the digital model, and therefore they just need to connect the programmer's software with a simulation, and then we can exchange the signals bidirectionally. And at this point, the simulation is no longer a self-regulated model with a predefined behavior. It becomes driven by the actual logic of this PLC program. And so our digital model transformed from the digital model to a digital twin. The digital twin sends the real signals to the controller, which evaluates the system states and returns corresponding signals back to the simulation. For example, these conveyors you can see here can now be switched on and off directly by the PLC program without requiring a physical system. Major benefits for this, we increase the safety. Dangerous situations can be identified here in this virtual environment, and we can handle this in advance in the PLC logic long before the physical machine is powered on. And this helps to prevent damages to the equipment and ensures that people working nearby the physical machine during the commissioning process are not put at a risk. And another advantage of virtual commissioning is the considerable time saving in office. Traditionally, the process follows the sequence. We plan the system, we buy the components, we manufacture it, and then we assemble. And only after that, we are able to check the PLC program. And the PLC programmer can start with the test. And only at that stage, it becomes clear whether everything is working smoothly or if issues occurs. And depending on the size and scope of the system, it is rare for a program to run flawlessly on the first try. So we have almost always adjustments to do, and depending on the complexity of the system, this can take a lot of time, like several days, to fix it. And yeah, most errors can be identified and resolved in advance by using a digital twin. And as a result, we can significantly have less real work on site. And this brings us benefits like faster commissioning and minimized downtime of the production, and shorter transition time between decommissioning the old system and starting the new system. And for our customer, that means they have better planning reliabilities. Here, this is a video, but it doesn't run. Oh, a little bit too fast. Here, that should be a video. But that's live. Okay. Anyhow, this is a video. Imagine that is a video. So in this video, we usually show how we commission it virtual, or in a virtual commissioning, we do the commissioning of a system. There we have a robot, a Stolpli robot, and we have a PLC program. The robot is controlled by the Stolpli robotic suite, and the machine itself is controlled by a real PLC program. And this setup allows us to run individual PLC cycles. So we can test them separately and in combination with the robot. And that brings us to the situation that we are able to check if we have possibilities to optimize the cycles, and we can ensure that we have collision-free robot motion. And by the way, that was a project which was carried out during the COVID-19 pandemic. That was a time, I think that most of us knows that, where a lot of industries have problems with their supply chain, and parts have not been available. And in that case, it was the same way. We doesn't have the possibility to buy the parts, and or our customer doesn't got the parts, and so it wasn't able to have an on-site commissioning in a traditional way. So it was not feasible under these conditions, and yeah, there was the problem that it has a significantly delay of that project. And yeah, that's why we did some virtual commissioning, because then we have been able to prepare everything to start the machine once the physical parts and physical components were delivered and the system was assembled. In that moment, we was able to switch on the machine and nearly everything was working fine. Yes, after we have successfully commissioned the machine, we have done the virtual commissioning successfully, and all of our processes have been thoroughly tested, we come to the stage of the real commissioning. Now we can load the PLC program into the controller and we can start the physical system. And once the machine is running, we have a bidirectional connection between the real system and the PLC. That means the system sensors can send real signals to the PLC, which processes the information and sends control commands back to the machine. The simulation has not just a unidirectional connection to the PLC. That means the simulation only receives the signal from the PLC, and the simulation follows the real processes without influencing them. And at this point, we talk about a digital shadow, a visual representation of the actual state of live production. What could be a practical use case for that? In a customer's project, we continuously records and stores all information of machines and robots like access values, joint positions, error messages, machine states, and we all save these information in an MES system. That is a system that runs like a database that documents the state of the entire production line at specific time points. And we can use these data sets and we can export them as a CSV file, for example, for a defined period. Then we import them into the simulation tool. And based on this information, we are able to have the entire system state, and we can visually reconstruct the whole situation that allows us to do some analysis and replication of error events. That means in the practical example, we have a machine unexpectedly shuts down during the night shift, and the next day we are able to read these stored data, and that allows us to trace exactly what happens and why. For example, for example, we have a machine shut down because a conveyor belt have been overloaded. And that is because an HEV wasn't charged and was not able to pick up the produced parts from the conveyor. And this is something we can find out with our simulation, or we can find out that maybe an employee opens a safety door or something like this. This makes the traceability of error analysis significantly more efficient and helps to prevent similar downtimes in the future. Together with our customer Maschinenbau, we implemented a digital shadow that simulates a complete warehouse system. The customer's tool, Custologic, is used as the central control system. And all changes made within this system can first be tested in the simulation before it will be transferred to the real system. And this allows employees to monitor in real time what the physical system is doing without having to be on the shop floor. And in this way, optimization potentials can be identified, processes can be improved, and decisions can be made based on the results of the digital model. And in the end, we are able to create a closed loop system where real systems, planning tools, and simulation tools are interconnected. The MES system transmits continuously live data from the production floor, and the digital shadow follows this information. And at the same time, the APS system provides information about upcoming production orders. And if we're using these data, we are able to do predictive analysis. So we can calculate the optimal time when, for example, a HEV should be recharged to ensure that once a task of a machine is completed, it has enough battery power to reliably transport the products to the next processing step. And maybe even this sounds like a future vision. This is already a state-of-the-art technology in our digital industry. So thank you for your attention. And now I'm happy to answer your questions you may have.
Thank you, Julius. I think this was a very interesting topic also for our audience, as we do have some questions for you. I would start with the first one. So how much time does it take to build a digital model? And what expertise is necessary? And how quickly can employees then get up to speed with the system?
Yeah, that is one of the most asked questions. And yeah, to give information about that, we say one thing is that we have around 4,000 parts in our e-catalog. That means we have machines, robots, and they can be clicked like by copy and paste, put them in the 3D world, and then we don't need to import CAD files. We have nearly everything in our database we delivered with us. And to create such a layout we have seen before depends on that how often you work with that, but it takes around 1 hour. Therefore, we give we support you as a customer. We give lessons, and that takes around 1 to 2 days, sometimes 3 days, depending how deep you want to go in. And yeah, so after that lesson, you are able to create such layouts we have seen before in around 1 to 2 hours.
Mm-hmm. Next question, what challenges can arise when implementing a digital twin, and how can they be overcome?
Mm-hmm. Yes, that is that thing is that after you set up everything, every part is placed in the situation at the position it has to be. It comes the biggest thing is that you need to you need to have the synchronization of the real time and the simulation time. That means like a robot, he want to pick up a 1 kilogram part, then he can move faster than combined with he want to pick up a 100 kilogram part. In that moment, the robot will move slower. And this synchronization is a little bit tricky, but in the end, therefore we have our project managers at DUALIS, where we can support you with this kind of problems. Yeah.
Mm-hmm. Okay, so the next question is also into the direction of iTAC. So I don't know if you're going to be able to answer it, but can we use the simulation tool to validate a new software update with the iTAC test environment before deploying it on the iTAC production environment? Can you say something about that?
Yes. Depending on what you want to do exactly. If you have a firmware of like a CNC machine, in that moment, we cannot simulate that so deep. But if you want to have an update of an existing SPS program, a PLC program, or you want to improve the program of a robot, that is exactly what we're doing with simulations, because we can, after you set up the machine, you commissioned the machine, the process is not finished. You come to the point that you say, okay, we can improve it a little bit. And the improvements can be tested in the simulation. And so that is a possibility to validate software updates. Is that, I see Martin Heinz comes.
Yeah, maybe to step in shortly. Yes, you are totally right. But if you're talking about MES and MOM, then we talk often about processes, right? And I think the question is related as well to a kind of a process. And yes, indeed, we had already a project together with a customer simulating the whole line. So, and we were able as well into the integration phase to simulate as well the behavior of the line. And so we'll be able to have a kind of a test before we start really to integrate the whole system on customer side. So basically, we are looking forward as well to have such a kind of a, let me say, implementation and simulation as well as a given solution. So we are working already on that. So if there's a dedicated interest, please be so kind to connect to us, and then we have a short meeting about it and to explain a little bit more in detail. But basically, yes, it's as well possible.
All right.
Oh, thank you.
We have 2 more questions. I'm gonna go with the shorter one first, and then see if we have time for the second one. Where do you see the use of simulations in daily operations?
Yeah. To give another example, we have customers. They are companies. Let's say it in general. There are companies who do some welding. They have welding parts, and they are produced by robots. The welding Porsche needs to be driven by the robot, and sometimes they have parts they produce several times, like 3,000 times, and sometimes they have parts they just produce one time, and therefore they can test the robot program in the simulation, and this is something what they do every day. And every day they developing new robot programs, and because for new parts for new orders they have, and then you need to produce new parts, and then they need to have new robot programs. And in such situations, it is really helpful to have a simulation tool like Visual Components, because you can test it and find out if you have collisions, and it makes it easier to program or to edit the program. So there are possibilities to use it every day in the daily operations.
All right, thank you. So any remaining questions we will answer afterwards, so don't worry. If you have any further questions, just don't hesitate to ask, and we will answer each one of them after the session or during the session in a written format. But we're going to continue with our next session. So thank you, Julius, again for the presentation.
Yeah,
and I think Julie is already with us to talk a bit about connectivity and other stuff. So Julie, you can share your screen and then start your presentation.
Good. Thank you, Alina. Can you see my screen?
Yes, we can.
Great. So thanks for having me. I'm really happy to be part of this summit. I think it's a great event that is bringing a lot of valuable information to simmer at the end of it. So for the passionate ones who have been with us since the beginning, I know it's getting late for most of you, so please do a few shoulder rolls or dance move as you wish. Stick with us. There's only a few sessions left. So I hope you still have some energy to listen to me. So as the electronic manufacturing landscape evolves, data-driven decision-making and real-time process control have become essential for competitiveness and quality in PCBA production. I guess some of you have heard about tariffs, about the challenges with the global economy. So this is getting even more important now to improve our PCBA productivity and also reduce cost. So in this session, I will cover with you the connectivity challenges between machines and system in SMT manufacturing, the different strategies for capturing meaningful data, and also the best practices for shop floor control and active traceability. So I hope that today's discussion will equip you with practical approaches for breaking down silos, achieving true shop floor transparency, and empowering your teams to make faster and smarter decisions. The story of enhancing PCBA manufacturing and shop floor control all starts with data. It's really the key to unlock process optimization. So we're going to talk about decoding the data silos. So all machines you have on your SMT floor are already generating and collecting data, but are often trapped within the vendor software platform. You might have a line with ASM machine, a line with Panasonic machines, and all of this data is kept whether in OIB or Panasim. And when you have multiple vendors, the data is typically never connected together. They don't always make it simple to send the data in an open format, and it's not easy to pull together all the different elements from the many vendors on the shop floor. I would wager guess that you have at least 5 to 6 vendors in one line, and it's just one line. You probably have more than that line, and juggling the different platforms to try and get a complete picture of what's happening on the line is difficult, to say the least. So trapped data can definitely lead to quality issues. Without a single source of truth, it's challenging to ensure the accuracy and completeness of data, which can affect product quality and compliance with standards. In addition, when the data is not shared between teams, it can hinder collaboration and continuous improvement efforts. Problems may not be communicated effectively or communicated at all, and opportunities for process improvements or innovation can absolutely be missed. And when the data is trapped in the different vendor platforms and not visible across the entire line and organization, too much time is wasted in manual data retrieval or reentry, which slows down production. When you are gathering all this data, everything will be fed automatically. So it really limits the amount of manual data entry. And not having the big picture can lead to delayed decision-making and the ability to respond quickly to issues on the line. You can target specific improvements without the full picture. Plus, as your manufacturing operation grows and new technologies or machines are integrated, data silos can become a huge obstacle. The lack of integration and interaction between systems can definitely limit the ability to expand or update the manufacturing process seamlessly. Factory digitalization is actually more complicated in electronic manufacturing than other manufacturing verticals, as there is no set standard or protocol governing all machines and systems. So when you think about semiconductor manufacturing, you can think about SESGEM, but with SMT manufacturing, there's been a headway with CFX in general. There's still an enormous install base with different types of machine, protocols, and formats. So while significant progress has been made in machine integration, we'll still come up against the persistence of data silos across the manufacturing ecosystem. So that means that each machine needs some kind of adapter tools to help extract and normalize data from the shop floor, because every machine will have different ways to communicate the information. Could be in a text file, and when we talk about text files, there's so many different formats. Can be a CSV, it can be an XML or a JSON file, could be shared with a proprietary format in a database, and there's all the different communication protocols as well that are involved. So that's really challenging, and domain expertise is critical. So using an off-the-shelf solution offering circuit board assembly expertise is a great way to overcome data connection and enable contextualization. So Cogiscan has been doing machine connectivity for over 20 years, specifically for SMT manufacturing, bringing that rich granular data on the shop floor and feeding that data to the rest of the ecosystem. With the Connect platform, you can tap into multiple data sources. The data is then enriched into a common format, and it comes built in with over 200 machine adapters, but also include a no-code platform that you can use to build adapters with custom machine, for example, with testers. So with Connect, obviously you can connect to the machine and collect the data from the entire production ecosystem. The value resides in PCBA manufacturing specialization, enriching data into a comprehensive and SMT production-oriented format. So the data is taken and contextualized by bringing shop floor control data, such as the work order information or consumption, into the equation. You can get really specific information about your pick and places. So you can know if you had mispick or drop components, from which feeder it came, from which head, nozzle, spindler you had the issue with, and all this data is available, and you just have to tap to it to know it. So all of this data that we can take is then transformed into traceability or visualization with actionable insights. All of this rich information can be shared with other systems to enable other functionalities, such as quantity tracking in your ERP, for example. So you can share this information via REST API, via different brokers, such as RabbitMQ for AMQ Pay or MQTT. So it's really flexible. And the key here is that you have to share this data with the different systems. Now, all that data is key for material management. And I'd like to cover the importance of having a shop floor solution that covers and understands all the nuances in PCBA manufacturing. Effective material control will save you money. And knowing that over than 75% of the cost of this PCBA is from components, you definitely want to have effective material control. And for that, you need accuracy. So accuracy in the storage location, accuracy in the remaining quantity, so that you know everything about your inventory. So by having each reel, tray, stick uniquely identified, you will have precise information that are not typically available in an ERP. So as you see in this slide, in the ERP, you will have information such as the material part number, the overall quantity, and the overall location. So you know that this part number is into the warehouse, but when you want to get it, it might be challenging because the warehouse can be big. So where is it in the warehouse? So you need to have precise information to be able to find quickly the parts that you need, because you want to reduce downtime. So with effective kitting and job setup, for a specific part number, you will know how many reel you have, what's their remaining quantity, and where they are. So you don't have to run around and just look for the reels. And all this information is key for proper job setup. Production management, such as having low-level alerts on the line before a reel gets empty. So you really need to get all the details about what you have in stock. Data synchronization with a closed-loop inventory management system plays a key role in optimizing the SMT process. So as an example, we have the material initialize and manage in iTAC. meaning that unique IDs are created and information such as quarantine material will be managed there. And we have this closed loop quantity synchronization between MES system and across. As components are used on the production floor, usage data is being fed to us for updating inventory levels. This process also includes synchronization with SMT towers and X-ray counters, providing a comprehensive view of inventory. The benefit here is real-time accuracy, ensuring that inventory data is always current and reflective of the actual stock levels, which minimize stockouts and overstock situation. And operators are being notified when a low level happens on the line. So your water spider, for example, would know exactly from which tower they can get the reel. And with this process, it reduces line downtime in the factory and reduces as well unnecessary operator movement, because we need to optimize everything. A key aspect of material management is sensitive material management, especially in high reliability PCBA manufacturing. Effective management of MSD in electronic production is a complex and multifaceted challenge. Preventing moisture-related failures requires strict adherence to a range of rules and processes across the entire life cycle of these components, from the moment they are received and labeled, through storage, exposure, baking, and assembly. So given the number of variables involved and the high cost of errors, it's not realistic to expect effective control using paper-based logbooks or spreadsheet trackers alone. Cogiscan offers a purpose-built MSD control platform designed specifically to meet these needs. And funny story, it was the first product we released to the market over 25 years ago. It provides comprehensive tracking and control for every stage of the MSD handling process, ensuring that the right rules are enforced automatically and consistently without relying on manual intervention. The advantage of using such a platform is the visibility across all the different machines need for MSD management and control for their different processes. So it will cover all the rules from storage, baking, and even placement. It manages as well rules such as the minimum remaining exposure time before moving further down the process. And interlock points can be added anywhere with the help of a product flow controller with machine communication. So for those of you who don't know what is a product flow controller, it's a device that Cogiscan has that you can connect to your conveyors using the SMIMA protocol, and it will stop the conveyor to prevent the board entering the machine if it shouldn't. So with interlock, the process could be stopped in front of the pick and place or reflow oven, for example, so that the product is not built if something is expired on it or if the minimum remaining exposure time is not met. Sorry. So data and a proper material tracking are the key for active traceability and control. In this section, we're focusing on how to guarantee quality at every step of the SMT process. One key aspect is the ability to validate and control critical elements throughout the entire SMT manufacturing line in real time. So for example, the system can interlock the line, essentially stopping production if it detects that the MSD has expired or even is close to expiring. This prevents potential reliability issues further down the line. We also guard against misloads. If the wrong materials or an incorrect programs are mistakenly loaded into a machine, the process can be halted immediately, preventing costly rework and scrap. Another control point ensures that each assembly follows its required process steps. So if an upstream operation is skipped, the line won't proceed until the issue is resolved. All of these controls feed into comprehensive traceability, active traceability, meaning every detail is captured and reported. This is invaluable for process improvement, for compliance, and customer reporting, because you have a complete holistic view of each product's manufacturing history and quality status. And ultimately, these measures don't just catch errors. They create a culture for proactive quality management where issues are prevented, not just detected after the fact. And I believe that's something you really want to have in your factory. So my message here is don't wait at the inspection before finding out that something is wrong. With the different elements of line control, you can prevent errors from happening. So from making sure materials and components are used under the right conditions, you prevent ahead of time that defective and expired materials are to be used in your factory operation. So with LCR control, you can verify that the electrical characteristic of components are accurate so that you can act if it's not, and make sure you don't use them. Time-sensitive material can be used to track thawing and expiration time for consumables such as solder paste, ensuring that the consumables can safely be used for production, following the manufacturer's recommendation. You can interlock production in the case material is expired. And one thing that you always want to reduce is the job setup time. You want to make sure your machines are producing at full capacity all the time. Kitting control is a great addition to your process, as you can prepare ahead of time future jobs to minimize the setup time. Whether you are using a closed-loop integration with a tower or not, operators can prepare kits by efficiently getting the parts. They can get them from a storage location, from a SMT towers. You're ready to run production, but you want to make sure your machines are properly set up for the boards waiting at the machine. With setup validation, you validate every element from machine program to component and location of the machine. If something's not right, it won't go into the machine. With route control, you will avoid manufacturing errors, meaning that a machine will interlock if you are trying to process a defective board or if a production step has been skipped. All of this control can be enabled independently of each other so that you can target specific process improvement to eliminate potential defect. And you just have to pick somewhere where you want to start. And then you can, one by one, enable all these different processes to ultimately have a fully defect prevention setup. To wrap up, we've explored how enhancing data management and control on the shop floor can improve quality, traceability, and efficiency in PCBA manufacturing. I really encourage you to consider how these approaches can be applied or elevated in your own manufacturing environment. So thank you for being with me today. We have some time for questions, and if you like more information or wish to discuss specific needs in greater details, don't hesitate to reach out to me.
All right, thank you, Julie. Thank you for the presentation. We do have some time for questions, and we have a few questions from the audience. First one is, are your solutions specific to PCBA manufacturing, or can they be used in different manufacturing industries? If yes, do you have use cases?
our expertise is really with PCBA manufacturing. We know everything about the SMT process and backend operations. So that's really our focus. The Connect platform, if you want to get data from your equipment and you are not running PCBA manufacturing, the Connect platform has the flexibility for you to create your own adapters to get the data. But that's not something that is typically done by us. So.
Okay. Second question is, we do not have machine connectivity at the moment. Is it something that can be done in-house, or what should be the first step?
So the short answer is yes, you can do it in-house. But there's a lot of challenges with machine connectivity. As I said, there's different standards that are present on the market. There's machine upgrades that will come up. So that means that you will have to update your connectivity solution maybe every time a machine gets updated or you get new equipment from new vendors. So a lot of our customers and people I've talked to have tried to do it by themselves, but at the end of the day, it was really challenging. You have to have knowledgeable resource in-house, dedicated resource that will be able to focus on connectivity. But then you always have to be up to date on the different standards, and you need to basically be a specialist in every standard. So yes, you can do it, but there's a lot of challenge that comes with it. And that's why we suggest to use an off-the-shelf solution.
Mm-hmm. Thank you for your answer. We do have a last question for you. Can quality management and repairs be tracked with your solution?
Yes, definitely. That's a part I didn't cover in the presentation. So the first step is always to connect to the machine. So from the AOI, from the SPI, AXI, we get a lot of rich information. We can get the defects, the component part number on which they were found, the reference designators. So that way you can, you know where the defects are, and also you can build the analytics and KPIs based on the defects you are finding. We also have a defect management module into our track, trace, and control platform, in which you can proceed with manual inspection, but also rework. So if you need some rework to be done, we have a visual task that would allow you to, by loading the board's design, you see the different defects that you need to rework. So that can be added in addition to all the other modules you might be using.
Mm-hmm. Let's see if we have some more question. No, it doesn't appear so. So I would say thank you, Julie. Thank you for your presentation. In case there are any more questions left, you can always contact us and we will reach out to Julie or make the connection directly. So that is not a problem. And right now we will continue with our next presentation, which is from Ferdinand from DUALIS. And he's going to talk about predictive planning and AI. So if you're ready, Ferdinand, you can share your screen and start the presentation.
Okay, yes, thank you, Alina. I hope you can hear me. And
yes.
And 1 second, also see my screen?
Yes, we can.
Okay, perfect. So let's get started. Yeah, welcome to the Smart Factory Summit from my side. And of course, welcome to my presentation. My name is Ferdinand Sule, and I'm a data scientist at DUALIS. And today I want to talk about more realistic processing times and delivery dates through predictive planning and AI methods. So let me quickly show you today's agenda. I will start with the pain points nowadays. So what are the problems today in the production planning area? And I will continue with the solution. So solution with predictive planning. And this section is divided into 3 parts. So first of all, creating the database, the data foundation, which is needed for the AI use case. And then I will explain the first use case, the more realistic processing times, and then the second and last use case, the delivery dates. In the end, I want to sum it all up and give a short outlook. And yeah, with that in mind, let's start by looking at where most planners are today. What are the problems with the deterministic master data? What you can see here on the right-hand side is a production plan calculated from our APS system, GAN-Plan. APS stands for Advanced Planning and Scheduling. And in easy words, it's a software which calculates the production plan. But this software is much more complex. The software enables you to optimally plan all orders based on available resources and capacities while accounting both schedule and cost requirements. So in easy words, it helps the manufacturers to boost their efficiency and get reliable delivery dates, even in very complex production areas. So today, the APS only looks to the future. And like I already said, the APS calculates the production plan based on deterministic master data. Furthermore, the analytical solution, which is calculated by the APS, is quite good or almost perfect at the moment of planning, but it deviates maybe 2 hours later, and our plan doesn't match the reality anymore. Why, or what are the reasons for this? We have 2 challenges today, or nowadays. First of all, we have external disturbance variables. So, for example, a machine breakdown can occur and capacity isn't available anymore for planning. And the second problem is because we are modeling our production landscape, our assumptions are not 100% realistic. So, for example, Christoph Stutt is a worker who needs more time in the evening than in the morning. So his scheduled task will take more time, and he is too slow. This results in a deviation between plan and reality, and we have to replan to fix this gap. Of course, the adherence to the delivery dates will decrease and the costs will increase. So far, we've seen why deterministic data drives reactive planning, but what actually can't you see today? Let's put your APS system to an, I would say, reality check. First, let's be honest, today's APS system can't tell you exactly where and when your plan starts to fall apart, but we want to ask or we want to answer some questions like on the left-hand side, how much and how quickly does your plan change? How much buffer does your planning need in which time window? Or even what's the cause for the delay in the production? So it's a kind of a root cause analysis. For this, we need one simple database. So we want to collect data from all systems available, like the first layer ERP system, or like data from the shop floor, from the MES, like from iTAC software or Accevo, and also from the planning side, so from the APS system, like GAN-Plan from DUALIS. We want to collect all the data, and then we are trying to answer those questions. For example, with GAN-Plan Analytics. GAN-Plan Analytics is a new module directly integrated into your APS, and it's a software which saves all planning data and, of course, all confirmation data in the background. Furthermore, with the collected data, we can compare planned and realized production plans. So we can see, do we really realize the plan? Furthermore, it's possible to analyze the progress of every production order, so we can see where and when is something changed in the production order. We can enable 2 use cases. I will explain in a minute. For example, the forecast of the processing time and also the forecast of the more reliable and realistic due dates or delivery dates. And to sum it up, we can say it unleashes the full potential of your production landscape through precise analytics and AI-supported forecasts. So I have to mention here that a connected shop floor is, of course, required to collect all this data. And if there are privacy concerns or if there are collected data of personal worker, then you should be aware of privacy concerns. But it's kind of a trade-off between privacy and accuracy, the precise personal confirmations are required for good analytics or for good analysis. So before we dive deep into the two AI use cases themselves, there's one undeniable requirement, and this is a clean, structured data foundation. So a data foundation that captures every planning snapshot and shop floor event from your ERP, MES, or APS system. So let's see how we can build this. The challenge nowadays, currently there's still too little use of historical data for the future, but this data is the requirement or the basis for data-driven projects. So our solution is quite clear. We want to save in an automatically way all the data in the background. So what you can see is on the right-hand side at the top, a progress of the result info over the last months. So you can see the count of early, on-time, and late production orders, and at the bottom, the related costs. So we want to collect all the planning results and, of course, also the key figures and record the production progress and the required resources. With that in mind, we can have the following advantages. We can check the consistency of the plan, so we can calculate a degree of plan realization, because we can say, okay, this part of the plan we really realized. Furthermore, we can monitor the planning quality, and we can derive a sensible planning horizon. So the payoff is huge. You can now compute true plan realization rates, keep an eye of the planning quality or the KPIs, and even create and define a planning horizon based on data rather than just a good guess or good feel. Okay, now we have our data, our table is set. We have every planning snapshot and every shop floor event in one place. What can we do with all that? And let's imagine the following scenario. Can we detect resource-based delays and then adjust speed factors manually, and then we optimize the complete plan? So we are starting again at the production plan. Most of us will know, but you can move around. You can see which scheduled tasks are scheduled, which work center is required, which worker, and so on. You can zoom in, zoom out, scroll down. And now the planner has one question. He asks himself, can I expect the resource-based deviations in the process times? So for this question, he can now use a new feature, a new tool. It's a visualization in this case. It's a color scheme under the color schemes tab and the production order. And it's called duration analysis activities. And what happens in the background is a trained AI model is asked, give me a more realistic duration based on those features or those influencing factors. So the AI model will predict an operation duration based on the historical data. And all features we can see here, the worker, the work center, are influencing the result. So yeah, the timestamp is important, the worker, and also the work center. So if there's a deviation between the AI prediction and the duration calculated on master data, then there's a color shown, or it's highlighted in a color. And if we are too slow based on the historical data, then it will be colored in red. And if we are too fast, it will be colored in blue. So with just one eye, I can inspect, or I can see based on the historical data, there will be a deviation. So what everyone should see is that the work center 03022 is kind of strange, or something isn't working here. So we want to check in a more detailed way what's up there. So we can use a new report. It's called Verlauf Stückzeiten Ressourcen. Right now, it's only available in German. But what you can see is at the top, you have the progress of the ratio of actual and target piece time. And at the bottom, you have a visualization of the same data, but in a different way, in this case, in the form of a distribution in a histogram. So what you can see is all the green bubbles are representing past operations, and we want to hit the 100% line because there we have no deviation and everything is fine. But what we can see is we are at around 200%, and that's a sign that we are too slow. The black line here is just a moving average to smooth the line, and yeah, we can see there's something strange. So what can we do now? We can jump directly into the master data and check the speed factor for this work center. And we can see, okay, with the actual speed factor with 100%, we are quite slow. So we can adjust it to maybe just 200%. So every operation scheduled on this work center will be twice as fast. Then we will hit the reality and we fix the problem. So it's kind of easy. To sum up the use case, right now we have the following challenge. We are assuming master data, which is rigid and possibly error prone, and we have to reschedule every time to fix our plan. We want a relationship or a causal relationship between the influencing variables and the real actual operation duration. So on the right-hand side, I have a little plot, which is a motivation. You can see the progress of the relative deviation of the process duration over time. And what we want to hit is the blue horizontal line, because there we have 0% deviation. And if we are under the curve or under the line, we are too fast. And if we are above, we are too slow. What we can also see is that the target time, which is visualized in the color, is adjusted several times over the years. And the moving average, this is the black line, is increasing as well. So what we can learn from this easy plot is we should stay in the year of 2020 because there matches the target time, the really realized actual time. So here it's quite easy to see, and it's a two-dimensional plot, but ask yourself, how do you factor in a machine type, operator skill, batch size, batch sequences, or even material quality and order priority all at once? Because those dependencies form a nonlinear pattern, and it's quite difficult to plot in a two-dimensional way. So that's exactly why our AI model is so powerful, or an AI model in this use case in general. It ingests every column of data, discovers deep causal links, and predicts cycle times with accuracy no human chart could match. In a simple way, you can imagine it as the following. We can feed the neural network or any other AI model with data, and the data has some features like the operation, worker, machine shift, and there are many more features possible like the temperature and the fab or the day of the week. And the AI model will be trained on this data, and it will predict a more realistic duration based on those features. Many AI models are here possible. For example, tree-based models like a random forest, or also a very known model, artificial neural network, which is inspired by the human brain and is very powerful to model those non-linearities. So with this in mind, we have the following advantages. Right now, we have a dynamic adjustment of the planned operation duration, and with this, the prediction accuracy will increase. And with a better prediction accuracy, the rescheduling effort will decrease, of course. Okay, that's the use case. And with this refined operation times, we will feed directly to the second use case, the more reliable delivery dates. Now we are here, letting AI turn all those realistic processing times and real-world resource data into bulletproof delivery dates. Imagine this, instead of quoting a single best guess due date, can we analyze machine availability, operator shifts, and even workload patterns, and derive a more realistic delivery date? Right now, the delivery date, which is analytically calculated, is very good. It's almost perfect, but we have, again, the challenge that the delivery date varies due to external influences. So, for example, a rush order or a machine breakdown occur, or the worker is ill, so we can't use the capacity anymore, and the delivery date will bounce around. The solution here, again, we want to feed a neural network with every bit of the historical data, like the worker, machine, utilization, order priority, and so on, and let it learn the true causal patterns behind the delivery dates. So with this, we can derive process data from historical actual data with AI. And furthermore, we can create a more realistic estimation of the delivery date and capacity utilization. In an easy way, you can imagine the following. You have a neural network, and it's fed by the feature set or by the input data, like I already mentioned, the worker, resource, and so on. The utilization maybe in an easy way can be modeled with the count of production orders in the system. So if there are many production orders, then we may have a higher utilization. So this is the input of the model network. And the network will predict a more realistic delivery date. In this case, as a distribution, the distribution has a big advantage I will explain in a minute. But the use case overall has the following advantages. The adherence to the delivery dates will increase, and of course, the planning security. So what's the big benefit of the distribution? What you can see here is the output of the AI model for one production order. And it's the cumulative chance of a delivery date over time. So over time, the chance of a successful delivery date will increase. Because it's real data, and that's the output from the AI model. This production order had a real delivery date. In this case, it was 17 days roundabout. And this use case is quite cool because you have the adjustable safety factor. I will explain in a minute. And the biggest advantage is best case and the worst case guess. So in this graph, you can see a red in the green area, and try to explain it very easy. You have a kind of best case delivery date, best case for the customer because it's quite fast. It would be 12 days. But it's kind of risky for the planner or for the production because it's just a probability of 30%. So I can ship very fast in 12 days, but just with a probability of 30%. So it's quite risky. On the other hand, you have a worst case guess. It's the worst case for the customer because you have to wait 22 days in this case, but it's quite cautious for the planner. So the advantage here is the user or the planner in this case can define their own security or risk preferences. And I mentioned the adjustable safety factor. If the planner sets up the safety factor for his needs, maybe he wants every time 50%, the AI model would also predict a point guess like it's usual. In this case, it would be 15%. So instead of promising T plus 10 days for every order, you offer a tailored date you really can keep. And with this, it's no longer guessing because every commitment comes with a confidence level. The big advantage, of course, the adherence to the delivery dates will increase and the planning security. This use case can be integrated in a step-by-step plan. So we have 3 levels of integration in this case. The first and the easiest one is ask the AI model for a more realistic date. So I have the production plan, and I want to ask for a more realistic date based on the historical data. So I need the AI model, and I asked it, give me the more realistic date. So it's the easiest way. The second integration step is like a warning pop-up. So you have your production plan, and in the background, all delivery dates are calculated. And if there's a big deviation between the analytically calculated delivery date based on the master data and the AI predicted delivery date, then there will be a warning pop-up, something like, be aware of production order 1020 or whatever. Here's something strange. So that's the second step. And the last and maybe coolest step is the autonomous scheduling with the new dates. So auto scheduling with AI predicted delivery dates. So this is the use case. Let's step back and tie both use cases together in the last section, and it's the summary. And we can see on the left-hand side a happy Gantt plan analytics user. And so we are on the home stretch. Let's recap what predictive planning really means to you. Predictive planning, or in other words, the Gantt plan analytics, is embedding statistical and machine learning models directly into your APS system. Nowadays, we have a good analytical planning with an APS system, but the potential of the historical data is not yet exploited. We have the following advantages with collecting data. We want to collect planning data and, of course, also the confirmation data. We can apply patterns from the past to the future, like I showed in the two use cases, the operation duration forecast and the second use case with the more realistic delivery dates. And the opportunities are quite clear as well. We can save costs because we have less replanning effort. We can reduce the costs of storage because the delivery date is more realistic. Material isn't so long in the storage, and overall we can increase the customer satisfaction because the delivery dates are now more reliable and more realistic. Overall, this will increase the product quality, and yeah, Gunplan Analytics, you don't need data science knowledge or something else. It's an universal use and of course constantly evolving. And the use case I showed to you are only the starting point. So further statistical analysis and applications are of course possible. So that in a nutshell is predictive planning with Gunplan Analytics, and we are looking back to the past to plan the future. And next we'll open the floor for your questions. And yeah, thank you very much for your attention. And I'm happy to take your questions now.
Yes, thank you, Ferdinand. Wait a second. Let me share the last slide. Yes. All right, let's take a look at the questions. We have some questions I can ask you. First question would be, what level of detail in the confirmation data do you need to keep the forecasts sharp?
Okay, it's a great question. If I understood correctly, the detailed level of confirmation is asked. We have a bare minimum what we really need. This is a start date and an end date, so the start and end timestamp of the confirmed operation, and the quantity and work center. So those 4 points are required: start, end, quantity, and work center. Then we can calculate, or the AI model can handle the data and can predict the duration. But in other words, if you have more detailed confirmation, like confirmation intervals, then it would be even better because the AI model can learn the real insights in the data and can increase the accuracy in the prediction. So in this case, more detailed data is better in this case.
Mm-hmm. Second question, can we remove operator details from the confirmation data to avoid privacy concerns?
Okay. Yes, the short answer is yes, you can remove the operator data. But here it's the same way. Our research shows that the human is a big influencing factor for the actual duration. I think it's logical, but yeah, our research showed it. And if you remove the operator information, then you lose the accuracy again. So here it's again the trade-off. If you have privacy concerns, yes, you can remove, but you lose the accuracy in the prediction. But I think it's okay. It's a trade-off between privacy and accuracy in the prediction again.
Mm-hmm. The third question is a bit longer, but we still have time for it. How large do the data sets need to be for the AI model to be trained and deliver reasonable results? This is the first part. And then typically neural networks require thousands of samples per class. How does it work in high variant factories with frequent changes? Do we need to produce thousands of orders first before the AI can plan?
Yeah, this is quite tricky, and the answer isn't easy because it's right in a basic neural network where we need thousands of data points for one activity, for example. But if you're using another AI model like a random forest or tree-based models, then we don't need as much data, like the thousands data points per sample. So a good rule of thumb is we need around about 3 to 6 months of data, then we can start predicting. But yeah, in this case, more data is even better. And it's also possible to have transfer learning. So even you can use an AI model which is trained on other data, maybe in another fab, and then use it for your own. Then you need less data. You can use the information already created in another model. So I hope it's okay as an answer.
I guess so, yeah. If not, then they can just reach out to us afterwards.
Yes.
Let me check. We do not have any more questions for you. So I would say thank you, Ferdinand, again for your presentation.
No problem.
And we are right now at the very last presentation of our Digital Factory Summit. So Jörg, if you're already here, you can share your screen and tell us how to master maintenance management as a last topic. You need to turn on your microphone if you already. Yes.
Okay. And now you can also see my screen, hopefully.
Yes.
Okay. Then I will start now. It was a very complex issue, or very complex session, the last one. It was not easy to understand for me, at least. But now we come to a very well-known topic. It's maintenance management. And my name is Jörg Tedenborg. I'm a sales manager for the iTAC MOM suite. And I think I've been selected for this session because I have some experience in maintenance management in my previous life before I started at iTAC. And I hope you will stay with me for the next 25 minutes because it's the last sessions. And because of timing, I would like to go straight forward to the agenda. And of course, I will highlight the question why maintenance management matters. And I will also refer to OEE. I've heard that many times today, but it makes sense here. And it's a little bit a different view on that. Then I would like to highlight some benefits of an integrated maintenance management solution. And after that, I will talk a little bit about the basic functions from the technician point of view. So what to do, where and when. These are basic functions. And then I think that's the most important point here. What are the maintenance strategies and how to find the right maintenance strategies? After that, I will present two use cases as examples. I will start with the corrective maintenance and then the execution of a maintenance task. Then I have three separate topics with planning maintenance, which is also very important, the history of all activities, and the mobile solution. And then I will give a short summary about the main benefits here. Okay, then I will again start with the components of OEE, and that makes sense here because maintenance has a direct impact on all three components. If we look at the availability, just to put it back in mind, the question here is how much time the machine runs versus the planned production time. And we all know that we have different potential losses here, like unplanned stops, like breakdowns, and also maintenance interruptions that take too long, that simply take too long. And the target here is to improve the availability, and therefore you need the right maintenance strategy. And when I say right, that's the question, what is the right maintenance strategy? But I will come in a few minutes to exactly this question. You need quick repair times by skilled workers, and you also need a proper planned and, in best case, optimized maintenance windows. If we look at the component performance, Yeah, there is a question how fast production run versus the machine idle speed. And the losses here are slow cycle times, microstops, and inefficiencies. And the target is to increase the performance. And everybody knows a well-maintained machine run more efficiently and have fewer slowdowns. And also a proper lubrication or inspection or cleaning can help to maintain the optimal speed. And just to look at the quality, there are the losses, the defects, rework, and scrap. And here's also the target or the goal to enhance the quality. Everybody knows here that that the worn out tools or unstable machine often lead to defective products, and that maintenance ensure process stability. Yeah, if we have these three components in mind, then we can look at the OEE figure in the iTAC MOM suite. If you look at this screen, you can see the different operating states here of a machine, the output quantity, and also the OEE figure with the different, with the three components. And if you have such a solution in place and you can measure the components in an objective way, then you can expect with a professional maintenance solution an increase of OEE between 3 and 6% in average, of course, and depending on the industry. This is the experience and also some figures from a consulting company who specialized on this issue. And if you know what it means, a 1% increase in OEE, then it's also possible to measure the monetary impact of investing in a maintenance solution. I think this slide is necessary just to motivate to invest in maintenance solution. This will pay out in most cases. Okay, then let's take a look at the overall integration concept. What you can see here is the iTAC MOM suite with the different modules like the TR for traceability or QM for quality management. Then we have the ERP/SAP service on the left-hand side, and we have also the MOM integration layer with the integrated machine. And we have this module here, the maintenance management, and the iTAC maintenance manager is fully integrated in the iTAC MOM suite. And this means that with an already established ERP or SAP service, the maintenance tasks or orders with the spent time and the consumed spare parts can be reported back to ERP because this interface is already there, and you have just to open a new channel for that. And with the integrated machines, you have the conditions, alarms, and intelligent models, which you can use for different maintenance strategies. I will come back to this issue a little bit later. Yeah, what are the basic functions from the technician point of view or the key features? The first question is always what to do. And this means we have to provide the technicians a prioritize task list, and in best case on a mobile device. And of course, this is important. Then they have to know when to do it. So this is about the scheduling of the maintenance task, and I will later show that you can do this in a very smart way. It's also important to know who should do it, and this is to ensure that only qualified technicians are allowed to perform maintenance. It's also important to know what is needed. That means we have to manage spare parts and tool Yes, and we have to make sure that this material is available when it's needed. We have to know how to do it, meaning that we have to provide work instruction and the documentation to perform the maintenance task. And last but not least, it's really needed that we get a history of all the maintenance activities. I've today learned that this could be a good source for GenAI. So you can ask for, if you have a problem, for a specific solution based on this knowledge base. Okay, but let's start and do a little bit deep dive on what to do. And there, the strategy is very important. There are already some, I would say, higher level maintenance strategies on the market, like total productive maintenance or reliability-centered maintenance. If you have them already in place or implemented, you can just take them and deploy them in our maintenance manager. But if you don't have anything, then it would be a good first approach to use a so-called criticality diagram. And this, I have to explain a little bit what this is. The diagram has 2 dimensions. One dimension is the consequence of an error, and the other one is the probability of an error. And then you have here the different segments with very low, medium, and high. And if you now look at a certain asset or equipment, you have to decide what is the consequence of an error and how likely is an error. If you take, for example, if you take a motor and you know this motor will run stable for the next 10 years and you can replace it within 1 hour and it's always on stock, then the probability is very low and the consequence of an error is also very low. And then we would decide, okay, this motor has the criticality of very low. And if we follow this logic, then you have low and medium and also high and extreme. And extreme means in this case, the probability of an error is very high and the consequences also of an error is also very high. If you know that, this way of thinking, then you can take the asset structure in the iTAC maintenance manager. For example, here, the cleaner, the cooling device, echo belt, and so on. And then you can assign the criticality to this asset structure, meaning you can say, okay, the flange package has a medium criticality and the cleaner it has an extreme criticality. Let's put this in mind, and we come to the maintenance strategies. And there are different strategies which are in common use. For example, it's the corrective maintenance. You can say it's firefighting mode, meaning that you only react when something breaks. And you use this strategy, of course, only when the asset criticality is low or very low. Then we come to the preventive maintenance. Here we are talking about recurring activities based on fixed time intervals or counters like operating hours. And this is normally used when the criticality is high or medium. Then we have the condition-based monitoring, maintenance as needed, you could say. And this is based on the actual machine condition. And this is used normally when the asset criticality is high or extreme. And last but not least, we have the predictive maintenance, where we try to predict an error or failure in the future using data and machine learning algorithm. And because this means a lot of effort and also cost, and this makes sense if you have assets with the criticality extreme. Okay, now we come to some or two use cases, or we can also say workflows. I will start with the corrective maintenance. And if we are talking about corrective maintenance, then it's always a collaboration between production and maintenance. That means the machine operator has a problem with the machine and he can fill in a service request. And this could look like this. It should be very simple, and the machine operator just fill in a short description. In this case here, there are some noise on the adapter here, please check. And then this service request goes straight forward to the maintenance department, and they have a so-called request list. They can view the request list, and this looked like this. And here's our request. And then they have to decide if they reject the request, if they accept, and plan a maintenance task out of this, or transfer this request to a maintenance task. And this is exactly what we want to do. We plan a maintenance task with a task description, with assigning a person, and so on. This is also very simple in the iTAC maintenance manager. It's thus just filling in the execution time, reserves the spare parts, and also the documentation, instructions, and so on, what you need here in this Windows. And after that, it will go directly in the task list for the maintenance worker or for the technician, and he can execute and feedback this task. And this is exactly where the next use case starts. It's the execution from the technician point of view, and this is a typical task list. And the first thing the maintenance worker has to decide what is the next task, and he can use different things for that, the priority, the location, and also the due date or the planned time here. And he can also check the required spare parts. In this case, one is missing here. He can view the documentation and instruction which he needs to do the work, and at the end he can acknowledge the task, meaning he can say how much time he spent for the activity, and some notes for the history, and also the spare parts he needed that has been consumed in this case. Okay, what are the possible maintenance strategies in the maintenance manager? As you just saw the planned maintenance, meaning it's a one-time task. For example, as a result of the service request, we have the preventive maintenance with intervals. You can see here a counter base. The interval is 6,000 hours, or a time-based, in this case, 1 year. We have the condition-based maintenance based on the actual machine condition or alarms. And we have the predictive maintenance here. And if we think when to do, then we are talking about maintenance planning, and therefore we have two options. We can use the advanced planning and scheduling, and in this case it is possible to do an automatic planning and also an optimized planning for both, for the
production orders and also for the maintenance orders. And you can take into account the machines, the personnel, the material, and the tools. This is a very comfortable thing if you can work with the advanced planning and scheduling. And if you don't have it, we have, on the other hand, also an overview of the schedule maintenance task for a certain time period. This is something which is also very important, the maintenance history, with the question, what was or what has been done? And it's always the case, or very often the case, if you have a problem, then with a machine or something, then you can look into the history. And for example, you can filter here with free text and look for a similar case. And if you select then this task, then you have here on the right-hand side a detailed view on the selected task with a brief description, with the time spent, and also with the spare parts. And this history gives you a complete traceability of the internal and external activities complying with the ISO 9001. And I've already mentioned the mobile solution. This is also very important for the maintenance department, simply out of the reason that they have to be independent of the location. And we have a smartphone optimized view here in our mobile solution. We implemented this as a so-called progressive web app, and we can provide that in 2 variants, for tablets with 8 inch or bigger, or for mobile devices smaller than 8 inch. And this app provides all functionalities required to execute and report a maintenance task. Yeah, we are almost at the end. I would like to summarize the benefits here in these slides, and what we can do here with our maintenance manager. We can improve the technician efficiency by giving them a clear guidance. We can support maintenance managers with a better planning of the maintenance task. We can provide full visibility of the maintenance operation. And of course, we can optimize the spare part management and also optimize the maintenance schedulings, especially if you use the advanced planning and scheduling. And last but not least, we can manage all maintenance strategies, including predictive maintenance. So I'm not sure if I'm good in time here. I think I was a little bit fast. You are.
That's
okay.
all right.
That's all right. But we still have some time for questions. But first, I would like to thank you for your attention, and I'm glad to hear some questions, if there are any.
Thank you as well, Jörg. Yeah, we have 2 very last questions for now. Okay. First question to you is, can the maintenance orders also come from the ERP systems like SAP PM, for example?
Yeah, this is an interesting scenario, and I saw this quite often, that they want to use the SAP PM system, but only on a high level, meaning that we just get the order from PM and do the work in our iTAC maintenance manager. Can you still hear me?
Yeah, we can. Yeah.
Okay. There was some noise in the background. So yes, it could make sense to use this orders, and then you can collect all the costs regarding the spent time and the consumed spare parts in SAP. But the operation in the shop floor is done by the iTAC maintenance manager. Yeah.
Okay, thank you. Last question, can the user interfaces in the maintenance manager be customized?
Yeah, this is also a good question, because the user interfaces should be as simple as possible. This is, I would say, the most important factor if you use a maintenance management solution. It must be very easy to fill in the needed data, and it's also impossible that you can extend the GUI with some extra fields. Yeah, this is a very important discussion that you really can customize, and we can do it. Of course, we have some mandatory fields, but in general, it's very customizable, the system. Yeah.
Mm-hmm. Okay, let me check if there are more questions. Right now, no. So I guess we are at the end of our very first Smart Factory Summit. I would like to thank every one of you for joining us. Just a few organizational topics from my side before we conclude. We will offer each of the sessions as a video on demand on our website, and we will let you know once they are available. So for every colleague or person you know who was not able to join us today, don't worry, they are still going to be able to see all of the sessions afterwards. And in case there are any more open questions left, we will reach out to you. And yeah, thank you from my side. And I think Martin also would like to say a few words at the end.
Yes, indeed. So yeah, we made it, so to say, at the end, right? We are a little bit ahead of time. So I think that's well okay for all of you if you are a little bit less time. Yeah, it was indeed the first time to organize this Smart Factory Summit this year with all the companies are belonging to iTAC, and the aim was indeed to present you, let me say, different opportunities and different, let me say, outlooks into the market, coming from MAS, MOM, taking over to APS, had some simulations as well inside, and then AI as well, an important topic on that hand side. And I promised into my introduction this morning or today, noon in Germany, that we will have a, let me say, information about different challenges we are like to face too. We tried to point out, hopefully quite clear, that we are able to provide different solution to came over on different pain points. So tackling different functionalities, different areas. And hopefully it was a interesting and beneficial summit as well and meeting for you. So thank you for joining the meeting. Yeah, it would be nice, and looking forward to stay in contact together with you. And whenever you have a question concerning the meeting today, or pick up some aspects out of the discussion or out of the presentations we did today, or even if you got the information that it's available to download the information, then would be nice to get the feedback from you or stay in contact, or to get in contact the first time maybe to discuss your challenges, your pain points, and to come over with a solution as well for you. So then I'd like to close the meeting. I'd like to thank as well internally to the whole team, as well for organization. Many thanks as well, Alina, you were setting up the meeting and organizing. Well done, well prepared, as well to all the presenters. Well done. Thank you very much, guys. And I think it was a great achievement today. Thank you all. And yeah, have a good day, have a good evening, and looking forward to see you and to hear you. Thank you very much.
Thank you all. Goodbye.
Bye-bye.